I'm MC Toon, and it's Toonsday night. And that means I've got a debate, and today I am debating with the troubling Tribune, who is here. Welcome, Mr. Tribune.
Thanks again for having me.
Yeah, glad to have you. In case people are wondering if I sound different or anything looks different, I am. This is a new computer setup, totally new since last week. So, if there's any problems, let me know. I'll have to fix them later, though. So, anyway, I saw you hosting a debate with Witsit and Globe Man and Globey McGlobeface on TikTok, and I think you also put that on. You streamed it also to YouTube, right?
Yep, YouTube and Rockfin.
All right, nice. All right, well, maybe people want to know who you are a little more.
Yeah, absolutely. Give me 1 second. I'm clicking through stuff. Awesome. All right. Yeah, folks, thanks for coming on. My name is Skylar. I'm the Troubling Tribune, host of the channel. We do conspiracy, controversy, debates, and other hot topics. So if you're new to my face, then be sure to go over and check it out. If you like it, hit the sub, shameless plug. You can also go check out my website. It's pretty cool, troublingtribune.com. You can learn some more. Yeah, but my favorite thing to do is to host Flat Earth, or I've dubbed them True Earth debates. That way we can get a wide audience. I don't want people to think that it's just flat versus globe all the time. We also have concave earthers, hollow earthers, and etc. So definitely a fun place to be. Although recently I did just get banned on TikTok for, I really don't know why. Didn't tell me.
TikTok's banning algorithm is terrible. So, and that none of the services ever tell you why. So how can you know that? How can you fix what you did wrong? So
it's tough.
Well, anyway, it seems you think the Earth is flat.
Yeah, I mean, I believe we have measurements. I believe that we have a lack of measurement of motion through space. And, from where I started off, I won't say I was completely ignorant to the topic. I had pretty good grades in school. I had an A in earth space science and, was actually very into the idea of like going to Mars one day, getting with NASA and, just having a whole bunch of fun out in zero gravity. And the more I look into the actual veracity of the claims and what I can actually verify, I find it, pretty lacking. So it's a good place to start, I feel. I always like to talk about the actual measurements of physical curvature and whatever else. Open game.
All right. So you said you have measurements of flat Earth.
Well, they're the same measurements that I'm sure you've seen already, and you'll claim that refraction or bendy light is responsible for the observation, which I will say, I don't disagree that refraction is a thing. It absolutely is. Light does bend when it goes through mediums because it, changes the speed due to the density. So I do agree that that's a thing that happens. However, to simply invoke it as a blanket term to explain every single observation that would seem to put pressure on the globe is, it seems a little disingenuous on the surface, but I understand why it has to be done.
Well, it's not just a blanket refraction. There's actual application of the measurements of refraction, right? The effects of refraction have been quantified. And so when we say that refraction is at play, we're not just saying it blindly and just to fill in any gaps. We're saying, well, there's actual, the application of Snell's law that we're doing. Right.
And where, if you don't mind me asking, where is Snell's law derived from, the equation?
I don't know the derivation offhand of Snell's law, other than that Snell gets credit for it. So does Descartes, especially if you're French. They call it Descartes' law in France and French-speaking countries.
And just to make sure that we're on the same page, or when we're talking about standard refraction, which is what I would consider the blanket refraction for the most part used, Standard refraction is, I don't know the exact number, but isn't it a certain rate, assuming a curvature over, assuming r or a radius?
Well, standard refraction, I generally don't use standard refraction. There's a wide range of different refractive conditions. So standard refraction comes typically from the measurements that Gauss did a couple hundred years ago in Germany. That's a certain index of coefficient of refraction. So a coefficient of refraction is something that you use to modify the measured radius of the Earth, and to include in the equations. It's a convenient way to do it. There's other ways to do it if you prefer, but that's
So when you
typically how it's
say,
done.
so correct me if I'm wrong in that understanding, but you said that standard refraction was derived from the known measurements of the Earth radius.
It was I wouldn't say derived. Gauss measured the effects of refraction. But yes, the measured radius of the Earth was something that was used in what Gauss did.
Okay. So for one, I would like to see the. Sorry, I forgot the train of thought on that one. I've had a rough day, honestly. So
Yeah.
prepare me for being a little less than prepared
You
as I would
tell
like to be.
people why. I think it's fair.
Okay, sure, no problem. So for those who who don't know what's going on, I had a emergency happen this morning. I woke up and my cat was all lethargic, not eating, drinking, and did not look very good. For those who know cats, that's pretty abnormal. They don't really show signs of being sick until it's probably too late. So we rushed him to the vet, and they hit us with a ridiculous vet bill that, honestly, anybody who's had pets knows it's not the easiest thing to be able to do. Those surgeries are quite costly, and there's very few options. There's no payment plans. I don't qualify for any of the CARES loans or anything like that. So pretty much had to ask the community for some help. And luckily they came through. We did a little fundraiser and was able to generate some cash to be able to make sure that my son's cat got the treatment that it needed. So I appreciate all of you pitching in for that. It was definitely an emotional roller coaster because that is my son's emotional support animal. Essentially, it is, you have to be in the house to know, but he is the sweetest cat. So we do appreciate all the love and prayers. Even for those who couldn't afford to support, no hard feelings, of course. I do appreciate just the positive vibes. And so, yeah, I was dealing with the veterinarian almost all day today. So that's what happened.
So yeah, I saw that on YouTube, and I thought, and I'm glad you did get what you needed so you could get the treatment. So I imagine my cat will be handed to me in within the next 2 hours at some point. One or both, or the dog too. So okay. So the what we were talking about, the effects of refraction, the measured radius of the Earth. Where were you going with that?
Okay, so we have, to make it simple, we have standard refraction, which was, you say measured. That was the question I had. How was the effects of refraction measured over a distance and verified?
Well, Gauss is. I haven't read it. I don't read German, but I do have a good number of them on mctoon.net/refraction, and I can pull it up. We can look at them quick here. So let me get.
And for the record, I didn't get any of my flat earthism from Eric Dubay, contrary to popular belief. I actually stumbled across the Matt Powerland real or photo video, which was pretty compelling. They're actually photorealistic paintings that I certainly can't tell the difference between that and the real thing. So I wonder if there is skilled eyes out there that are able to do that.
Did you act? Matt Powerland isn't serious.
But he's labeled a comedian, yeah. But I've actually watched him for quite a bit, and he's quite serious. He does believe that.
Okay. Oh crud! Unfortunately, I cannot actually share my screen in Zoom at the moment. I'd have to quit and restart Zoom.
Oh no.
New computer. But I can tell you what, I will send you I'll send you the link, and then you can look. I can read a little bit. There's a couple that are in particular that are good. All right, hold on. Let me get I'm gonna switch my screen to video capture. Where did screen capture? Oh my goodness.
This reminds me of when I first got my Mac that was donated to me a couple months back.
Okay, so the website is mctoon.net/refraction. It's got a list of a bunch of different measurements of the effects of refraction. The top one is a really good one. It says monitoring the refraction coefficient in the lower atmosphere using a controlled setup of simultaneously reciprocal vertical angle measurements. So they use two theodolites apart from each other that were automatically measuring constantly the variation in the elevation that was apparent of the other theodolite. So these theodolites had a target on the face of them so that they could automatically track them. But the nice thing about that particular one is that it has a list of a bunch of other measurements of refraction at the beginning of it, including referencing some that are in German and then given a little summary in English for it. And I did get a couple of them, the German ones, and translated them, the kind of interesting ones. But there is a graph. If you scroll down, the first graph on the page there shows the effects of refraction at different times of day in different conditions. And the real important part is on a sunny day, later in the day, the amount of refraction goes up dramatically, and it peaks well after sunset. And then if it's overcast, it doesn't have nearly as dramatic. So that first graph that has a big spike on the left side, and then on the right side has just some, chopping up and down.
Why do you think that is?
Why? That's because the sun isn't heating the water. I think these were over water, both of these. Yeah, this is 5 meters above the water.
And this is a question that I've asked myself a few times, and I've talked to different globers who've said different things. So I am curious to see how you'll answer it. So we're seeing more refraction based on these charts when the sun is out. And that's obviously because it's warmer, heating up the water, creating more moisture. That obviously makes sense. What about when it's colder?
It doesn't make sense. What does humidity in air do to refraction?
Well, humidity, I imagine, because it's thicker, I imagine that would be causing the light to bend down.
Actually, humidity has the opposite effect. If you look at the molecular mass of water, H2O, and the molecular mass of oxygen, O2, or nitrogen, N2, both oxygen and nitrogen have a higher molecular mass than water. So when water displaces a molecule, when a molecule of water in the air displaces a molecule of oxygen or nitrogen, which is the primary things in the air, it actually reduces the density. So more humidity actually will cause lower refraction. Not that it's a huge amount, but it does go the opposite direction from what a lot of people think it does. It feels thick to us. Like when you go outside on a humid day, you're like, oh, it feels thick, but that's just our feeling. That's not actually refraction.
I mean, I could agree with that maybe the feeling isn't necessarily refraction, but I mean, it definitely feels thicker, denser. I mean, I have a hard time believing that when it's a humid day that we're not experiencing denser air. than when it's a not humid day?
Our feelings are inconsequential when it comes to actual real measurements of refraction.
Okay. In that case, so if I give you, even if I give that we have a measurement for how much light bends through certain density medians, which I could definitely see how we'd have that. No disagreement there.
Yep.
When I'm looking and I'm trying to, granted, I'm going off the top of my head, when I'm going into the Walter Bislin Earth Curvature Calculator and you put in the standard refraction coefficient, I guess the question I would have, you would just say that it's measured, but the Earth radius goes into play into the direct formula. So, yeah. Okay, so but the Earth's radius was determined before the measurements of refraction were determined.
Yeah, they're measured in different ways.
So, what was the first way that it was measured before we had calculated for refraction?
The earliest that people typically say is Eratosthenes.
Okay, so you're going with the sticks and shadows.
Yeah, that's the earliest that I'm aware of. Maybe there's others. I did it myself 4 times.
I mean, I'm not disagreeing that we can get the shadow to be in different positions, but specifically, if you're doing the Eratosthenes experiment, the claim that I've heard is that you have to have at least 3 observers, which for one, Eratosthenes.
Just 2.
Well, you have to be able to establish the difference in the shadow relationships, and you can't do it with just 2 shadows. See, one is an exponential relationship and one is a linear relationship. How do you determine the difference with just 2 observers?
Yeah, you actually only need 1 observer, as long as you know the subsolar point. So Eratosthenes knew the subsolar point was in Syene. He knew that because previously he had been in Syene and had looked down the well and determined, oh, on this day of the year, the sun is directly overhead. And now we know where the sun is. We know that the sun goes over the Tropic of Cancer on around June 21st. And then it goes over the Tropic of Capricorn around December 20th or 21st. And same thing for the equinoxes. It's over the equator. So we know where the sun is on those days. So we don't need an observer at those positions. Unless somebody's like super incredulous, like, oh, I need to really have proof that the sun is directly over the equator on the day of the equinox. That kind of incredulity doesn't really get you very far, right? People don't question that. But I've heard people question, whatever. So we know where the sun is, and we can use that, and we can use your position, use your latitude to know how far you are from the sun. So I live in Minneapolis, 45 degrees north latitude. On the equinoxes, the sun was about 45 degrees in elevation. So I know that the angle there of that triangle that we're looking at, and I know the distance from myself to the equator is 45 times 60 nautical miles, or 69 imperial miles, which is about 3105 miles, right? And so we can then we can use that, and we can hypothesize 2 things. We can hypothesize that the Earth is flat and that we can create a triangle. Or we can hypothesize that the Earth is a sphere and that the sun is very far away. And then we can use those 2 things, and we can test them, right? So I can use my angle with the flat Earth hypothesis and get the elevation of the sun in Minneapolis is 3105. But when you're at 30 degrees north latitude, you do the same thing. You get a different size triangle, a different elevation of the sun. You do it at 60 degrees north latitude or 60 degrees south latitude. You get a different elevation of the sun. Every latitude, you get a different elevation of the sun, hypothesizing flat Earth. For the Eratosthenes style measurement of the radius of the Earth, or just if you want to do it as an experiment, right, you can have multiple observers. And they will get then a radius of the Earth that agrees with each other. And I did this. I have it on my website. We can go over that, sort of. I can't show it. I can't share it. Anyway, it's on, if you look on my website, search for Solstice, I have a link to all the data. So 1 observer can get you a radius of the Earth. You can do 3 or 4 or 5 or 10 to get confirmation of the radius of the Earth. So there you go.
Okay. So just to kind of take it back, because you kind of went on and we're like, well, we know this because we've measured this here, and then we've measured this over here, and measured this over here. And I get that we've taken subsequent measurements, after. I'm talking about establishing first principles. And when I asked, like, how was the radius first derived? You said Eratosthenes. And admittedly, Eratosthenes, there's only 2 points that they had. There was the subsolar point over Syene, and then there was the actual observation point in Athens, right? So, or which city was it? Doesn't
Alexandria, I think.
Alexandria. It's one of the A ones. Anyway, so at that particular time, at least as far as the story goes, correct me if I'm wrong, there was only those 2 observation points. We didn't have the observers all over the world with those different measurements. We only had Eratosthenes in the 2. And admittedly, he did have to assume that the light rays were coming in parallel, which granted, we don't really ever see, looking at the sun. I get that you can measure shadows, and some of the shadows that are closer together definitely, can seem parallel. But in any case, kind of going off on a tangent. So Eratosthenes had only 2 points. I had a conversation with Blitz PhD about this, and he was in full agreement that in order for it to be proof one way or the other, you have to measure the relationship in the shadows, because it's no secret that the sun would appear in different places based on your location. If you're only dealing with 2 of these locations, then you're not going to be able to get the discrepancies than if you had 3, 4, 5 observers. So if you don't have more than 2, then you can't establish the difference in the relationships of the shadows, and the difference between the shadows on a curved surface and the shadows on a flat surface, a linear surface, is just that the shadows do a linear relationship, meaning they grow linearly as the sun moves away, versus the spherical model, which the shadows would go exponentially. It would increase exponentially as the sun went away because it's curving. So how did they establish it back in Eratosthenes' day with just the 2 observers? How was that proof of establishing the radius?
I didn't propose that Eratosthenes was proof of anything. It was simply a single measurement of the radius. So when I did it myself, I hypothesized both flat Earth and globe, and actually did it as an experiment. Eratosthenes wasn't doing it as an experiment. It was a given going into it that the Earth is a sphere, and it was a given going into it that the sun was very far away. When I did it, I hypothesized those 2 things. So if you want to talk about, an actual experiment, I'll talk about mine. But we got into this because you asked what was the first measurement of the radius of the Earth, not proof. So the measurement of the radius of the Earth was done by Eratosthenes. That's it, just the measurement.
I mean, I guess I can give you that. There was some nuance there that I wasn't understanding, but yeah, I guess I get what you're coming from. You can accept it as a measurement so I guess the next question, the obvious follow-up would be, how much refraction is assumed when taking those measurements?
Now, Eratosthenes did not include any refraction in his measurements. I have in mine, and it was smaller than the margin of error of the measurement that I made. So like the shadow length was 121 inches, but the chalk mark that I made was about a ½ inch wide. So I have a plus or minus ¼ inch at least on either side of that. So when you this was for the December 2019 solstice. So when you include the error bars in that and then actually add the refraction adjustment is less than the error bars of just the length measurement because of the thickness of the chalk line.
So, and this was, so we're just going to go with your experiment, since obviously you've done one. It just makes the most sense to talk about that.
Yeah.
So you're saying the margin of error, what is the margin of, well, you said a plus or minus quarter inch, right? So what is the expected length for a flat earth assumption?
There's no expected length for anything. We're just measuring, so we didn't have an expected length.
So what, I'm sorry, I'm trying to follow you. So you said that we took the measurements and we assume a flat earth,
Yes.
and then they didn't work.
Yeah. So the way it worked is for flat Earth is I'll go with the numbers are easier if we look at the equinox. So measuring the angle to the sun, the shadow gives you the angle to the sun. There's other ways to get the angle to the sun, but a shadow is a low tech way to do it, and so that's why I was doing it that way. So it gives about 45 degrees on the equinoxes from Minnesota, because I'm from Minneapolis, because I'm at 45 degrees north latitude. About it was specifically did I write it down? I recorded it. Oh, I know where it is. 45.02083. So I chose a place that was very close to 45 on purpose.
I'm sorry, my internet kind of cut out a little bit. You cut out in the middle of your sentence, so I don't know what you said.
So I chose a location that was really close to 45 degrees because the 45 degree line runs through Minneapolis. So I chose a parking lot somewhere that I could do this at, and I returned at the same parking lot each time. So from Minneapolis to the equator is 45 degrees of latitude. Sailors have been using this knowing the knowledge of the distance of a line of latitude for centuries. In fact, France derived the meter based on the distance from the North Pole to the equator through Paris. So that's the original definition of a meter, is 10,000 kilometers from the North Pole to the equator. So we know the distance very well between each line of latitude is 69 miles, 111 kilometers, or 60 nautical miles. And so I'm 45 degrees north. I can multiply that by 69 to get 3,105 miles. That's how far I am from the equator. So on flat Earth, I'm 45 degrees from the equator, 3,105 miles from the equator. So we draw a triangle, and I can get some paper and I can do it right now. Right there. Here's flat Earth. Right there. I already have that line. Got a ruler. All right. Okay, this is for flat Earth, right? Here's the sun. Here's where I was, and here's the equator, right? And since 3,105 miles there, right? This is 90, 45, 45. What's this height here?
Hold on. So the line over the 90-degree angle is the equator?
Yeah.
Point? Okay, and the other point is where you're observing from?
Yeah.
Okay. And where are you located?
Minneapolis, right here.
So, and what degree were you actually looking at the sun at that time?
What degree? It was 45 degrees north latitude, and the angle to the sun was 45 degrees.
Okay.
It's not coincidence.
Right. So you're asking what that line over there on the other side of the triangle.
Yeah. So what's this? I mean, this is a simple triangle, right? If this is a 45, 90, 45 triangle, this height is.
Yeah, it's the height to the sun.
But what number?
I'm sorry, I can't see the exact number.
3,105 is this on the bottom here. That's my distance from the equator to where I am. So what's this height right here? Solving that triangle.
Honestly, I don't know. I don't have the calculator in front of me.
It's 3105.
Same thing. Got it.
It's the same, yeah.
Okay. Just wanted to double check.
Yeah, it's okay. If you haven't done trig lately, I wouldn't expect it. But if you've graduated high school, you've done this, right, in the United States.
Been a little bit since I've done it without, hands on.
It's okay to be rusty. So that's the height of the sun on flat Earth from Minneapolis. The problem is, though, if you go to 40 to 60 degrees north, right, or to 30, right, and I had somebody in my that did the test with me that was at, just a second, he's at 31.35. He's near Jerusalem in Israel. And when he did this, he got a different height of the sun, assuming flat Earth. So we're hypothesizing flat Earth, testing flat Earth. He got a different height of the sun when he did that. And when somebody at 60 degrees north, and in this particular one, I didn't have somebody at 60, but people are there. People have done it. It's not something new. They get a different height of the sun for every one of them. So how many suns are there? One. So it can't be at all those elevations simultaneously. But when we hypothesize that the Earth is a sphere and that the sun is very far away, and we do the same type of measurements, the same type of, we're just solving triangles, we get the radius of the Earth as our output. And in this, the one 6437, 6471, and 6498. Those are without refraction included. So we've got an agreement just on those three different observation points. So that's an Eratosthenes style measurement, three different locations, and they are in agreement with each other for the globe, and they contradict each other for flat Earth. So what can you conclude scientifically from that?
Well, if I was to do the false dichotomy and thinking that there's really only two things going on here, that either the Earth is flat or a sphere and nothing in between, and that's what's explaining the observations, then yes, I could definitely see how you would conclude that the Earth is spherical. And I also agree with you and double down the point that you were making to steelman it even more, that I actually know a flat earther who has actually since converted, but I think he converted back, Riz Walden over on TikTok, who actually organized an Eratosthenes style experiment where they attempted to measure the height of the sun. And what you're saying is completely accurate. What you do find is that the sun is in a different height for each observer. The only issue that I have with all of that is the foundation of it, which correct me if I'm wrong, but the foundation of this is, spherical geometry, obviously seen through, in the Euclidean space, correct?
Yeah.
Okay. So obviously we're making these observations from what we see. We have papers that are coming out. I say we, but that's actually false. It's not me. And I don't think it's coming directly from any like flat earther or anything like that, but that's beside the point. There are studies being done on vision, the way that we perceive reality, and the AI visual software is being updated to, instead of being Euclidean-based geometry, it's being proven that we actually see in hyperbolic space. Have you heard or seen anything about this?
I've heard that, but measuring devices don't see in hyperbolic space or don't have issues with visual perception. That's why a shadow length isn't subject to our human perception errors.
Okay, so
right.
And you're just basing it just off of the shadow length, and you're saying that, well, we're just perceiving in hyperbolic space. We don't actually exist in a hyperbolic space. If all we see is hyperbolic space and all of our measurements arguably have to be done from our own perception, how do we conclude that we actually do exist in this Euclidean geometry? Where's the verification?
Yeah, because the measurements weren't done from our visual error, our visual perception. They were done using instruments.
So how does the instrument correct for a us existing in hyperbolic space.
We don't exist in hyperbolic space. Just
How do
our personal perceptions are sometimes error prone. So, but an instrument that's designed to measure angles measures angles correctly within the capabilities of that particular instrument, right?
So how does an instrument, let's take a sextant, for example. How does a sextant measure the angle to an object?
So you line up the distant object you're looking at, and you line up something else. Often it's the horizon and a star, and there's a mirror that's half silvered there, and you can actually see the horizon in one part and the star in another part, and you line them up with each other, and then there's a physical arc on it, and you actually look then and read the angle off of it. None of that is going to be affected by our human erroneous, our ways of approximating angles. The actual instrument is doing it. It's designed specifically to get accurate measurements for angles.
So I can agree with you that the sextant is definitely going to be able to give you a more accurate angle of what you're seeing, but you have to start with what you're seeing. You see the star in the distance, and then you line the sextant up to that point. So if the star is in a different spot because of your perception, because we are seeing in hyperbolic space, then how can you claim that the sextant is actually somehow self-correcting, despite the fact that we're aiming it in the wrong spot because our perception
because
is
we're not aiming it in the wrong spot. It's not that it doesn't have to correct for hyperbolic space. Our eyes can sometimes make errors in the Euclidean space that we live in and incorrectly measure things when we're just using our own human perception to try to measure angles. But the sextant and reality both live in Euclidean space, and so it doesn't have to correct for that. We are the ones making the error when we are just estimating angles.
So we probably, just to be completely fair, we probably wouldn't want to rely on a visual-based tool if we're talking about correcting for human error and what
we would definitely be happy to use a tool, right? But not just our human perception.
Okay. So obviously we should be able to agree that if we are seeing a star in a slightly different position because we're seeing in hyperbolic space, that a sextant is not going to make an angle measurement to the corrected position. We don't have the corrected position calculated or anything like that. We just point and shoot. So is there another way or another tool that we can have that doesn't rely on the human, human sight or human perception?
It's not relying on human sight to do the measurement. The actual measurement is done because there's an arc there, and there's lines drawn on the arc and measured very precisely on the arc. That's how the actual measurement is done.
I get that part. I'm talking about like where you're pointing the sextant initially. So if we're seeing the star in a different position than its true position, because we're seeing,
we're not seeing it in the wrong position because of our errored vision. What you're talking about is humans are not good at measuring angles between things. It's not that we're not good at seeing where something appears to be. So if you look at it with your eye and you say, oh, I see something right there, and you look at it through an instrument, the instrument will also see it right there. But if you look at something and you look at something else and you say, oh, that looks to me to be 12 degrees between them. And then you take an instrument and you actually measure the angular difference between them, and you find that it's 43 degrees. That is the type of error that a human can make. We're not good at measuring angles. We're not good at seeing from some other perspective, some other position, the angular representation, angular relationship between different objects. So if I'm sitting here and I'm looking at an object over there and looking at an object over there and saying, oh, well, let me change the angle. Let me say, tell that other object there about when it's pointing to the right spot. We're not good at that. We will make errors in that. But if you go to that other spot and you get a theodolite and you measure that theodolite, then you'll get it correct, because theodolites are specifically designed to not make errors based on human perception.
Well, admittedly, all a theodolite is doing is measuring the angle away from level, right?
No.
Well, I mean, ideally, when we're talking about flat Earth debunking,
Theodolites can measure lots of different things, not just the angle from level.
they can, but I'm talking about for the purposes of this discussion, when we're talking about theodolite measurements, what we're going to want to focus on is the way things drop in the distance, right?
No, not at all, because you were talking about humans' errors in measuring things, right? And so you're probably specifically talking about a study called Direct Measurements of the Curvature of Visual Space by Jan Konderink and Joseph S. Lapin. That one?
Let me check. That might be. There's actually several papers on the matter.
Yeah.
And there's even a paper that's showing that the more distance that there is between the observers, the greater the spherical axis will be measured due to the fact that we're seeing in hyperbolic space. So,
yep. And that is all about humans' inability to estimate angles. That's what it is.
I'm just confused on if we are talking about a great distance and we're pointing and shooting first and foremost to then get the measurement. I'm just curious of how we correct because you already answered it. You said we don't have to correct because we're not seeing the star in a different position. But that, doesn't that fly in the face of what we were just talking about?
Not at all. So let me. I have the article on screen right now, and I put a link to it, the DOI link in the live chat. Actually, I'll send you the because I don't know if you have a copy of it or not. So there's the DOI link. And I know Witsit brought this up the other day. So they give this introduction about how they did it. They think this is important, and I'd share my screen, but like I said, I can't share it to you. So if you scroll down,
I'm actually watching the screen.
So
it's a little left behind, but I am catching it.
Okay, so in the setup here, they have these people with the remote control, and they're aiming this box. There's this cubic box there that has an arrow sticking out of it, and then from some number of some distance away, they're aiming that arrow towards that looks like a ball up on top of that other tripod, and so they're not standing at the actual cube there. They're standing at a distance away from it. And then there's another diagram right here, figure 2.
Sorry. What was the name of that study again that you're referencing?
Direct Measurement of the Curvature of Visual Space.
I will send you this one as well. This is a different one. It's actually called Hyperbolic Geometry and Binocular Visual Space by Samantha Zook.
Yep. Okay. And by the way, theodolites don't have binocular vision. So here is the figure 2, and you can see down at position V at the bottom there, that's where the person is. At position P, that's where the arrow is. And at position T, that's where the target is. So what they're testing is a human's ability to estimate the angle of that distant arrow pointing to the target. Right? That's what they're actually analyzing in this particular paper. It's humans' ability to do these angles, to measure these angles. The thing is, how did they measure the angles between them, right? For real, because they got the people to estimate the angles, and then they actually measured the angles. What instrument did they use to measure the angles?
Well, I'm actually not familiar with this paper, but I will say the fact that they did it close enough to be able to verify the angles empirically, definitely adds weight to it. That's what I'm looking for the reciprocal angle measurements.
Yeah. So I'll tell you, they used a theodolite. So they put these instruments at different locations, and they had people estimate their ability to get the angles. And they used a theodolite to actually get the measurement to see how far off the people were.
And we're
right?
talking left to right angles or up and
These
down?
are these are left to right angles. Yep. And and they had this isn't a big study. There's only 3 participants, and they were the people that were doing the study, so they weren't single blind, double blind, any of that kind of stuff. So it's a good experiment, but a better one with a larger sampling, and single or double blind would be even better. But here, this is the actual this is the meat of it. Here is these different triangles, and you can see these are based on the size of the internal area of the triangle, and when people were closer to the measuring device, hold on a second. I've got a cat, and I have another cat incoming. Hold on, just a second.
Adorable.
One at a time. This is Turtle. Hi, Turtle.
What's up, Turtle?
He's noisy. He's cranky sometimes. And this is the sweet one. This is Raccoon. She's really sweet. And then, okay, my goodness, we got all 3. This is. Oh, calm down. She doesn't. Dogs don't like being tossed around like this. This is Penguin. Say hi, Penguin. Right there. Nope.
What a crew.
There you go. Okay. All right. Thank you. Told you it happened. Okay. The angles, when they were close, they estimated the angles one way, and then when they were far away, they estimated the angles the other direction. And that shows in these triangles here. The 3 innermost triangles, they are bigger. The 4th one was very close to correct, and then the outer 2, they actually got the angles were too small. You're seeing that on your screen right now.
Yep, looks like a was it concaving triangle?
Yeah. The triangle's going in a different direction. So this shows that human perception is flawed, but they used a theodolite as the tool against which human perceptions were measured. Right now, the other paper, I haven't seen it, but I think I have. But because Gleam is the source of all of these, the binocular vision portion of it, right? A sextant doesn't rely on binocular vision. Neither does a theodolite. Neither does a shadow on the ground, and neither does your camera on your phone. You can install an app to measure angles with it. It's not relying on human binocular vision to measure these angles either. It's an instrument that's designed to measure angles accurately, so it's not susceptible to these types of errors.
So I guess what I'm getting at, to make it as simple as possible, when we're talking about like great distances, and I'm wondering if we would be able to agree on there being a limit on how far that could go, where before the discrepancy would be too great that you would pretty much have to angle the device a completely different way in order to get an accurate measurement from the observer. But basically,
we won't have any agreement there. There's no reason to think that an instrument that's specifically designed to measure angles can't measure angles.
Well, no, we're not
regardless of how far away they are.
No, it's just again, I don't know why you keep misunderstanding this particular point. I'm not saying that the angle itself to a thing cannot be measured. I'm saying to find the specific the actual location of the specific thing to measure the angle to it accurately would be the thing that would be in question, right? Not the fact that a thing can measure angles if you have the accurate location. We know that it can. We're talking about if something has been distorted in space for some reason or another, whether it be hyperbolic space in this instance, we can easily replace that with refraction. In any case, how would a theodolite or a sextant correct for the fact that something is actually displacing in space relative to the observer position?
And how specifically is it displacing in space?
Right.
That's my question to you. You said it's displacing. I'm asking, how is it displacing? What's the cause?
So, man, let me try to wrap my head around this one. Perspective would be the cause. I mean, I'm not sure what the
perspective is easy to apply with triangles. This is an application of perspective right here. Right? So when you measure this angle, perspective is how we apply this, right? We know this distance. So perspective tells us how high it is, because perspective is how big something appears based on how far away it is from you. So the gap between the ground and the sun is perspective. And because of the distance, we can just apply triangulation, which is applying perspective, to get the elevation of it. So if the Earth is flat, then the sun must be 3105 miles high, at least for me, on the equinox. That's perspective. So what else could be involved?
I mean, again, you've narrowed it down into this really specific scope, to try to make it like, oh, you gotta have to wiggle out of
It's
this
easy
one.
to do, though.
Again, I know that you can create a mathematical assumption, and the assumption is based on the physical phenomena of what we observe in real life is that things are dropping as they get further away. You're assuming that things are dropping because of curvature, when in reality that cause and effect relationship hasn't been established.
Actually, in this instance, I'm having nothing to do with curvature. This is hypothesizing flat Earth, right? You see, that's this here. This is Minneapolis, and this is the equator. No curve there. This is hypothesizing flat Earth.
Okay, but
I'm applying perspective to flat Earth to get the elevation of the sun over flat Earth, right?
So again, I get that you've done this calculation and that you have done it with, we've taken into account the measurement for refraction, right? The known refractive index. So we know exactly how much that sun has bent through the atmos through a certain distance,
Yes.
right?
Yes.
So in that experiment that you did, just to be completely honest and point blank, you actually took the refractive index from at least within probably within 1,000 miles of you and the sun, because the sunlight would have to, it's a 45-degree angle. It's not like you're looking up. It's got to go through, a whole
it goes through much less of the air than something that's low in elevation.
It's
right?
45.
And the steeper the angle, the less air that it has to go through.
Right? Steeper as in like up high or down low?
Yeah, when you're looking up high. So
right.
On the June solstice, for example, I measured, I have it up right now. The angle I measured was, I have a spreadsheet with a large number of measurements. Let me make sure I got that one.
Yeah, are you talking about the one with all the reciprocal zenith angles?
No. This is the 4 times that I measured, and I'll send it to you. There you go. There's the Google. You can look at it later, but it's on screen right now. So it was 68.9 degrees high was the sun when I was in June 21st of 2020. And the refraction that there you go. So, and a refraction gives us an adjustment of the angle. Now, these I got from the 1778 Nautical Almanac, or specifically the Nautical Ephemeris. So the arc minute angular adjustment is, the problem is for you that it doesn't help, but it doesn't help you. But because refraction causes distant objects to appear slightly higher. So the sun would actually appear slightly higher, not slightly lower for flat Earth. It doesn't help you. It actually works against flat Earth for refraction to be included. But I was happy to do it. So
I'm sure.
It doesn't make much difference. It was negative 0.85 arc minutes was how much at 45 degrees elevation. That's how much you adjust. So you actually add to the measurement.
Awesome. So I guess the question that I have to kind of narrow it down to the specifics, like what the heck is the difference? I know you say that, okay, if we do this measurement and we take this calculation into effect, we can't get the exact height of the sun, right? Let's say I give you that. What would we expect to see if we did have an actual set real height of the sun over a flat Earth? What shadow would we expect to see? How much different is it from the spherical shadow that we supposedly see?
Well, if the Earth were flat, then you would expect all of the triangles to give a very close elevation of the sun, regardless of your position. So, how high is the sun over flat Earth? You'd be the one I'd ask. How high is the sun? I could do the math for you if you tell me that.
Yeah, I mean, I don't know. So that's the thing. Can't
Okay.
go up and actually verify the
No, you
distance.
can. You 100% can. Because this would tell us how high the sun is over flat Earth. Right here. This would absolutely tell us. But it doesn't work. It never works.
Yeah, I think we would have to agree to disagree on that point. Because again, without having somebody or some way to actually verify the physical location of the object, then that's all we have is a calculation of where we could expect it to be.
So then you could not then make the claim that you think that the sun is local.
I don't know what the sun is.
Okay, so you have no claim about the sun then.
Right.
Okay.
I was trying to determine how the angles proved definitively the sporosity.
Yeah.
Because that's what I started talking about was the spherical measurements.
So. Yeah, they do. They are in agreement, and so I have my 4 specific measurements, which do include refraction.
Do you have a and forgive me if this question's bad formed. I thought it was an interesting one. Is there a source or some sort of scientific paper that backs up your claim that the instrumentation that relies on our ability to correctly pinpoint the visual location of something that's thousands, potentially thousands of miles away, that instrument will be able to correct with that, or that would not affect our ability to use that instrument to measure the correct angle?
Yeah, theodolites and other instruments are calibrated. They're specifically designed to measure angles. It's the only thing they do. How far away the object is doesn't have any impact on whether or not it can accurately measure an angle.
Yeah, I think we're going around in full circles. Okay, so let me take it back to the when we're determining the radius of the Earth. You admitted that we determined that before we had the measurements and understanding of refraction. So the obvious question would be, how did we accurately determine the radius without this determination, especially considering that there are instances of extreme refraction where we can have refraction that we're able to see even hundreds of miles past what we're supposed to be able to see?
Yeah, so you would definitely not want to use highly refractive instances as the cornerstone of your measurements. And there are many examples of that. For example, Eratosthenes' style, like I did, the adjustment due to refraction was less than 1 arc minute. So the amount of refraction is rather slight. So you definitely want to use, instances where refraction is lessened. So there's other ways to do it. Surveyors are experts at dealing with these types of issues, and they have for many centuries measured the size of the Earth. You have Everest, or Everest if you're in England, that was one. I'll give you a couple. George Biddle Airy, Alexander Ross Clark, Bessel in 1841, and Everest in 1847 were all measured the radius of the Earth to a high precision. And they included, it's not based primarily on vertical measurements. So they're
What is it primarily based on?
horizontal measurements. So what they're doing is these are surveyors. They survey the distance across some area. So Everest did it across a large portion of India, and so you have your latitude longitude at one side, you have your latitude longitude at the other side, and you very precisely measure that distance between them. And they can get to within, even in the 1800s, they were getting within meters across those distances. And so when you know the specific position, because you can through different methods, you can get the position of each of those points. And so you know what portion of the radius of the Earth that you're dealing with. You can get an accurate radius of the Earth's measurement for that particular latitude. There's others where they'll do north-south ones, and they'll get longitudes, and that's how you know the difference between the polar radius and the equatorial radius of the Earth. And most of those are horizontal measurements. They're primarily doing triangulation. They'll measure a baseline with an actual physical device. Sometimes it's a chain. Sometimes they use 3-meter long rods that are underneath a tent so that the sun doesn't expand and contract them dramatically. And they'll go end to end to end for many kilometers. And then they'll do it back and forth, both directions, to get a real precise measurement. Those are within 1 or 2 centimeters typically. Then they do triangulation off of that using theodolites.
We're talking about, again, just making sure I'm on the same page. You're talking about geodetic surveying or plane surveying?
These are geodetic surveying.
In the 1800s?
Yes.
So, again, I'm going to fact check this right now because I was just running across this last week, and I was seeing that we were still using plane surveying until the 1900s, and that geodetic surveying didn't really come about till after that.
Yeah. You'll need to fact check that a little more.
I'm doing it live.
Yeah. And actually they didn't really make a distinction between them before a certain time. They did. There are techniques that they've done to simplify some of the surveying that they do if they're not doing it over large distances. Let me see. There it is.
Correct on that. Yeah, I came out in 1807. That's my bad.
Yep. I have a stack of books right there, and this sits on here for when I do TikToks, live streams. So let me get my stack of books out of here, because the bottommost book is my surveying book. There you go. So there's Elementary Surveying, an Introduction to Geomatics from Galani, and my dog got that. Look at that. Naughty dog. I have a PDF of it that I mostly read, but there you go. It has it does talk about some of the different techniques that people use. One of the specific differences is when you're doing differential leveling, they specifically have techniques that they've used that they've developed that what you do is you take how much do I want to get into it? You take your station where you're measuring from, you measure forward and backward, 2 directions, and you measure against a stick, and then you get the elevation change of that stick. One direction you add, the other direction you subtract, and that gives you your differential. The reason why you add and subtract, and the other portion that's important, is that the distances as much as possible are the same, is because when you add one and subtract one, the curvature of the Earth is added and subtracted, giving 0. So it actually takes into account the curvature of the Earth when you do that. So built into planar surveying is accounting for the curvature of the Earth.
Right. Well, again, it's accounting for that drop that again, I guess you're within your right to assume is curvature if you like. So the thing, and I'll give just a real world example that, anybody of any intelligence should be able to understand. And it's really simple, but it's probably going to get laughed at because you can easily take the cop out of, well, that's just a video game. So that has no bearing in reality. So you can say that to what I'm about to say, but I don't think it'd be very helpful
Well, then why are you saying it? All right, go ahead.
Curiosity. So again, I do play a little bit of video games, not a whole lot, but just a few. And I do know that most of the video games out there, especially the ones I play, are all, flat maps, big shock. And the one that I've been playing lately, of course, is Fortnite. Fortnite I enjoy because there's a bunch of areas of high elevation and low elevation. And when you start looking at things the way that we do, you start to notice certain things. One of which is that Fortnite map is it's a flat topographical plane. They're even, I think they're throwing shots at the flat earthers because they have water like spilling off the edge of the sides of the out of bounds. So there you go. There's where all our oceans are going. Just kidding. But in any case, one thing that I noticed is that you can actually witness a drop in distance from the horizon at varying elevations. So, and this is a flat map
on
Fortnite.
Uh-huh. But how far away is the edge of flat Earth?
So I don't have a
on Fortnite. On Fortnite.
Oh, I don't even.
Not far.
Smaller.
Not far.
It's a lot smaller. Correct. Yeah, it's a lot
yeah.
smaller than it would be for the Earth.
Yeah, and again, it's just an application of perspective, which is done through trigonometry. All right, I gotta get these books out of here. Hold on, before I do that,
I would actually agree with you completely. It is a factor of perspective. Yes.
Right there, Neil Stephenson, good books. All right. So Samuel Rowbottom said this. It goes all the way back to 1861. He claimed that the horizon always rises to eye level. And the test that he did was to go to the top floor of the Brighton Hotel, the Grand Hotel in Brighton, which is 12 stories. And he said the horizon must drop a lot if the Earth was a sphere. He didn't actually do the math to figure out how much. He just said that it should drop a lot. It's not too difficult to figure out how much it should drop, but he didn't do the math. And then he did not use a theodolite. He used an 18-inch long metal tube with a string across the end to measure the drop. Yeah, that's what Samuel Rowbottom used. Not a good measurement device. Very large margin of error. Actually, who knows what the margin of error is? He never actually qualified it or quantified it. But when you use a theodolite, even from that elevation, you can actually measure the drop of the horizon. And you can predict how much it should by an application of trigonometry, both for flat and for the globe. Now, if the Earth were flat, and you've already said you don't know how far away the edge is, right?
Yeah, or if there's even an edge.
And that doesn't help you. Because if there is an edge, then there would be a drop, a very small drop, 0.01 degrees, depending on where you are. If there's no edge, if it's an infinite plane, then the drop approaches zero as the size of the plane approaches infinity.
Well, if we assume absolutely no other factors, then yes.
Yeah. And refraction would cause it to appear slightly higher.
I'm not even talking about that. I'm talking also about the opacity of the air as it continues on. Obviously, if you're looking through a density gradient, the further that you look through it, the more muddier it's going to get. And eventually there's going to be a diffraction limit. It's well known that our eyes have a diffraction.
Not a diffraction limit. It would just be, there'd be so much stuff in the air that it would just get fuzzy.
All right, diffusion limit.
There you go, diffusion. The problem is, we don't see that. I don't know why I brought that up. We don't see that. If the Earth were flat, we would not see a crisp horizon. That we would always see this diffused horizon. But we see a crisp horizon often.
So a crisp horizon can happen simply from something small on the ground being slightly higher than the rest of it. So if we're talking like an observation over water, literally any wave can cause you to see a crisp horizon that's in the distance. So that's just literally a factor of
Oh,
perspective.
again, whenever you say perspective, you got to understand. I can draw a triangle and do the math for it.
Sure. So go
Right?
ahead and draw. You can draw a straight line. We can pretend that that's like the base flat line of the sea level. You can put a boat that is all the way at the end of the page, and then you can put a 6 foot. There you go. And then you can see how the wave can block the bottom of everything that would be considered the horizon, and you would assume that it's Earth. And I will say, while you're drawing that, even though we do disagree, I do admire and appreciate somebody who is at least passionate and having fun with what they're doing. So
Well,
I do
thanks.
appreciate you having me on.
I thought you were going to say you appreciate my artistic ability.
It's
Which,
gorgeous.
if you were to do that, then we'd know. All right. So yes, so a very high wave, but the problem is that when you go higher, you have another guy up here.
Yeah, it just takes more distance at that point. You go higher. That's also geometry on a flat surface.
Hold on. So this guy, who's just a little bit higher, should have nothing obstructed just because he's a little bit higher. All this can be done by an application of trigonometry.
Yeah, you're actually right. Yeah, you are increasing the field of view and thus also proving that even if the Earth is flat, you can still see further by going higher up.
The problem is, though, that this doesn't actually work when you apply it. So, all right, I can. The another side effect of this new computer is that I have to resync my entire Dropbox folder. So I don't know if I don't know if I have this synced yet. So let me check here. It's not yet synced. Crap. So I was in Florida in February.
Oh, nice. That's where I hail from.
Oh. Are you familiar with Red Pill Philosophy?
It sounds really familiar. I probably stumbled across the channel here and there.
He was known for his high IQ research and for having lots of tabs open.
Nice.
You'll notice I have a tab open here. All right, let me see if I can force this to sync right now.
Somebody in your chat said that ChatGPT confirms that the Earth is a ball, and I think that is one of the worst arguments I've ever heard.
I agree.
I've gotten ChatGPT to say that it is 100% possible for heliocentrism in its entirety to be false. So, not sure if we want to rely on ChatGPT as the arbiter of truth.
No, ChatGPT just makes answers that sound appropriate according to its neural networks. So, all right, let's see. It is pulling it up right now. There we go. All right, and I won't be able to send this to you at the moment. It's on my computer. It's not online anywhere at the moment. Duke Nukem says, would I debate Quantum Eraser? I would, but not where he has a mute button. Or where Nathan Oakley has a mute button. I've challenged him before, he won't. So
yeah, I think hiding behind a mute button is pretty cowardly, in my personal opinion.
Yeah.
I'd much rather neutral platforms.
All right. It's all right. I don't know if I'm going to be able to do it. So when I was there, I got video using a P1000. I'm borrowing from Joe Hill, who's F'd Up World. He was in the chat earlier.
Yep, he was on my show last night.
Okay. He's a good guy. I like him. So the from the beach near Pensacola towards Alabama, I could see hotels and buildings in the background, and I could see the waves. The problem is when you do the math, right? So if I'm at 10 feet high and a wave is less than 10 feet high, but let's say it's 10, that's a ridiculously big wave. If there's a 10-foot high wave, there would be surfers there, right? The bottom more than 10 feet was obstructed, right? But if I'm 10 feet tall and the wave is 10 feet tall, then the most that can be obstructed is 10 feet. The math is simple.
100%. You're 100% certain of that.
Yes.
So no matter how far back that boat is behind that wave, it can only ever be less than 10 feet.
Yeah.
You care to draw it?
Sure. You don't get this?
I really don't, because to me it seems it doesn't seem logical at all. If you have a wave that's in the so let's take the exact same example you used before. Let's not change the elevation of the person. Let's change the distance of the boat. Keep the distance of the first wave the same. The first wave is going to be the same height, going to be the same size, but the boat in total has angular size has decreased. So the wave will be able to block more of the boat. That should be painfully obvious. Either that or I'm about to look like a complete fool. Either way, I'm excited.
Okay. All right. Now I'm going to have to draw a boat. It's going to be terrible. I'm just going to draw a rectangle. All right. So here's what I have. I got flat. I got this. This is the water mountain wave in the middle, right? Observer and the building there. So we can just draw right across from the different points.
Make sure to have the one that's halfway as close too. That way you can see the difference between the close one and the one that's further.
Right.
That way you can tell definitively that it would in fact sink. Again, due to angular size decreasing of the object as it goes further.
Yeah. And you can the angular size again. I dropped my ruler. The angular size again is an application of perspective. Right. So all right. So here it is. There's the wave, and there's the two objects that are past the wave. So the wave and the observer are both at 10 feet, and there's the straight line of sight. This is, excluding the effects of refraction. It's the bottom 10 feet of this is obstructed, and the bottom 10 feet of this is obstructed. Nothing more. But we can look at the angular size difference. I'm going to change to a pen so it draws thinner.
I'm trying to send you something in Discord as well.
All right.
Just something basic about.
All right. So it's harder to see. Let me see if I can get a little closer. You can see here when you're ready.
Go for it. Sorry.
So I drew two blue lines that show the angle to the observer. They're both very off of horizontal, very small off of horizontal here. Right? So the angular size doesn't actually change anything. It's still that line from the observer at 10 feet to the wave at 10 feet to the buildings or boats at 10 feet is all that gets obstructed.
Okay, I'm trying to wrap my head around it just based on the lines that you drew, and I'm going to try to apply like a little bit of math behind it. So the angular size of the first building, the one that's closer, what would we even call that? I'm trying to think of a good way to quantify it.
Building A.
What's that?
Building A.
Yeah, building A. And we'll just say that the angular size of building A is shoot.
Alpha?
No, I'm trying to use a specific number so that we can see the relationship between the two of them.
Oh, you want to give a number?
Yeah.
The angular size between horizontal and the bottom? Just to say, 1.
Sure.
And the angular size of B is going to be 0.9.
Okay, just 0.9 because they're so close together. But what if we extended it back even further? Would it decrease in angular size?
The thing is, it's an arctangent relationship. So as you get farther away, the amount of the angular change, it doesn't, it's not linear. It's an asymptotic relationship.
I'm sorry, what's a asymptotic
An
relationship?
asymptote? So an asymptote approaches a number but never gets to a number. You see that in a hyperbola. Know what a hyperbola is?
Yeah.
Okay. So an arctangent is that type of relationship. So that's why it's a trigonometric function. So when you double the distance, it reduces and when you go from 10 feet to 20 feet, right? You double the distance. It goes from one angle to a smaller angle. And then you add another 10 feet, you go to 30. It doesn't reduce as much. So you might go from 1 to 0.9 and you go farther, you go that same distance. It doesn't go to 0.8. It goes to 0.87. And you go again that same 10 feet, 10 mile, 10 meter, whatever. It doesn't go to 0.7, it goes to 0.85. And you go again and that same distance. It doesn't go to 0.6, it goes to 0.84. You see, that angle doesn't shrink linearly when you increase the distance linearly.
So it doesn't necessarily have to shrink linearly. That's not necessarily what I'm referring to. You claimed that the 10-foot wave would never be able to block more than 10 feet of the building.
Yeah.
However, if there was, and I'm going to get extreme with it just to make the point home, even if the Earth, even if you assume that the Earth is flat, you can still agree that things are going to shrink in angular size as they go off in the distance, obviously. So even to the quote vanishing point where it would get to the point that you couldn't even see it. So if you have a 100-foot building, you back that baby up 100 miles, then all of a sudden you have a little speck of a building. Are you going to tell me that that speck of the building is still going to be able to be visible behind a 10-foot wave?
Yeah, only the bottom 10 feet will be obstructed. To the quality of your instrument that you're using to look at it, right? So if you have your eyeball, it's only so good. If you have a telescope, that's a small telescope, well, it'll be better. And if you get a large telescope with a big lens, a big aperture, then you'll be able to make it out even better. But no matter what, it's still just the bottom 10 feet that's obstructed, no matter how far away it is.
I will say, McToon, the reason why, and that you're just going to go back to the actual tools that we use prove it. Even though the tools are relying off of our ability to accurately perceive things, the drawing that you're using is assuming Euclidean geometry. We're literally seeing, and for all intents and purposes, living in hyperbolic space. I mean, there's no evidence that the geometry we live in is Euclidean if all we ever perceive is hyperbolic space.
So all that you're saying, all that we perceive, all that our human perception is hyperbolic. I don't agree with that. That it's just that way. I think there's more to it than that. But all of the measurements that we do are based on Euclidean application, and they're correct. Unless you can show a measurement that isn't correct based on Euclidean geometry. Not human perception, an actual measurement using an appropriate measurement device.
Well, again, if we're talking about like getting the accurate measurements and whatnot, and I know that we do it today with perfect accuracy. I've seen sources that's, man, I should hesitate to say it because I don't know exactly what the name of the source is right off the top of my head, but there are sources that claim that when they were doing the initial geodetic surveying officially that they had a margin of error, and that any measurement that they took that fell outside of 85% within the expected known range, which was based off of other elevation angle measurements to the sun, and then the longitude lines being derived just by splitting a circle into 24 equal parts. So they take this framework and assumption, and then anything of their observations that do not fit within 85% of this assumption get completely tossed out. So this is why we say
you should really have that citation ready when you say that, right?
Yeah, I know.
So when you do surveying, when people do surveying, they you take a collection of measurements, and this happens in any precision measurement. You make a collection of measurements, because when you make many measurements, you increase your accuracy and precision. Well, it affects both of them. And so you get a better quality measurement by doing many of them. You get more significant figures in your final measurement if you do many of them. Now let's say that you did a bunch of measurements. Let's say you did 5. Let's start with 5. And you measured 2.0, 2.1, 2.3, 2.2, and 7.8. Now, if you did those 5 and you got this 7.8, what would you do with that 7.8? You'd look at that and you'd say, something probably went wrong with that. Maybe the guy read the wrong number. Maybe it wasn't a 7 and he actually read the 2. Or maybe he wrote down a 2 and it looks like a 7. Maybe, that there's any number of reasons that could cause the error. It could have been a blunder. It's one of the words they use when they're doing measurements. It could have just been any number of things, right? So when you do that, you say, all right, that 7.8 is not a statistically important number. But depending on your methodology, you might just exclude it. Say, we only need 4 measurements. We're going to get rid of that one because it's obviously not correct. You would definitely not look at that and say, well, all these that are jumbled around 2.0 are wrong. It's definitely 7.8.
Right.
You wouldn't say that, right? So then you go more. You say, you know what? We don't like that. That's not good enough. We have our 4 and that one outlier. Let's go back. Let's do another 10. And you do another 10, and you find this time that you do the same thing, and you get another one that's 1.0. Oh, okay. All of these are right around 2, and we've got a 1.0 and a 7.8. Well, the 1.0, again, is an outlier. It's not as big of an outlier, but it's still an outlier. You look at that, you say, okay, well, that, maybe we still include that in our final measurement. Maybe we don't. Again, it depends on the methodology that you're doing, right? And that's what they do. They do these statistical processes to them. And you don't just average them. You also do these things where they get a standard deviation and a standard deviation of the mean. And so when you have a standard deviation, you know what that is? When I say standard deviation?
Go ahead and use it in a sentence.
Use it in a sentence. I'll draw a picture. It's going to be on the same thing here. So we've got... All right, there's our, and this really should go to 0 here, right? So right there, if you have a collection of numbers and most of the numbers are right around the number, the middle there, your standard deviation talks about how far away you are in this grouping, right? That's a tight standard deviation. Then you can do say you did another measurement, and you got this wide standard deviation, right? You can look at that and you say, this isn't nearly as good of a measurement because they're not all bunched around the same number as much. We have outliers, positive and negative. So when they do statistical measurements, you get this standard deviation in the end where you say, well, if it's a good narrow standard deviation, we know that we have a high quality measurement. If we have a broad standard deviation, then we know that there's some problems with it. So you might say, well, we want to go back and do the measurements again, or we might just note that and take it into account in our final analysis. So when they're saying anything over 85%, that might be just part of the methodology to say it's too far outside, it's an outlier, we're not going to include it because we have enough other measurements. So if they're like, well, we only want 10 measurements and we did 20 in each place. If we get rid of the ones that are outside, we still have 17 measurements. We're still good.
I mean, ideally, that would be the correct way to do that. However, that's not what I believe is happening. But it's really pointless to argue it without the source. Just to be quite frank, I'll have to take the L on it for now. Just to be fair.
Okay. Brenda Debate says that I look a little sunburnt. Yes, I am sunburnt. PT Tony, who deals with this much more than I do, says the standard deviation is the mean difference between observations and the sample EAM. Sample EAM? Oh, I think he mistyped it. The mean difference between the observation and the sample EAM. Is that right? So
Where do you want to go with it?
So there's somebody in chat. It's funny. Marissa Keelan, who was on a few weeks ago, and she's going absolutely bonkers in email to me. And she actually claimed that there's no such thing as a south-facing shadow. Even on flat Earth, there's a south-facing shadow, right? And in any time in the southern hemisphere, there's going to be shadows facing. I don't know why she said that. And so I sent her some pictures of south-facing shadows, and somebody did a video of south-facing shadows because he's in Australia. And she's just gone nuts. And she's in the chat right now going crazy.
That's funny. I will say I do think, just logically off the top of my head, that there would be south-facing shadows. So, I mean, I would like to have your back on that, but I don't think
I appreciate that. She also said that Sirius, the star Sirius, had to be the pole star because she thought it was the only binary star, which is completely wrong. After that, several different astronomers came to me and said about 85% of the stars that we see are binary stars, including Polaris. She said Polaris can't be, but Polaris is a binary star.
Yeah, I see my first set of binary stars out of my amateur telescope when I was in 10th grade. So, I mean, there's definitely out there.
Yeah.
But I will say, just to address one of these other people, it's like 90 minutes, and we're still waiting on a measurement of flatness from TT.
There you go.
And
I should let you present the measurement.
The measurements. Well, so that's the funny thing, right? So you kind of already did on your website where you're showing the spherical access and in some cases lack thereof. The question that I would have is how small, and can you show this with like math or geometry, both obviously because math is geometry. Can you show how small the triangle would have to be in order for there to be no spherical access?
Well, there's no pure too small. It's due to the quality of the instrument, the ability of the instrument to measure the angles. So a theodolite that can measure to 1 arcsecond accuracy has a margin of error of at least plus or minus half an arcsecond. So if the total spherical excess is somewhere less than what there's 3 angles in that, right? So if it's less than 3 arcseconds, then potentially it could be within the margin of error of that instrument. The theodolites that they did to do these surveys, like in the transcontinental triangulation and the American arc of the parallel, they used theodolites that were more precise than that, and they did many, many measurements. And those many measurements were more precise because they did their statistical whatever, the processes and the methodologies that they did. And in the end, the actual spherical excesses were all more than zero, but some of them were very little amounts more than zero, like less than an arc second more than zero. It's because these triangles were rather small. So the measurement error of those particular instruments and the spherical excess overlapped in the margin of error in the excess. So those are not the ones that would be strong evidence for anything in either direction. Now, Whitsitt has identified that some of the interim measurements were, he thought, less. But the problem is that he didn't actually look at the whole process. So when they measure these angles, I'll go over this a little bit and see if it makes sense. They take the theodolite and they take one direction and they say, this is our zero. Everything to that is zero. And so then that's where they set their benchmark. And then they measure all the way around to these different points, right? So they're sitting on a pier on the East Coast, somewhere in New York area. And they're like, okay, so here's a pier over on the other side, and here's a spot over here, and here's the top of an insane asylum. Actually, I think the insane asylum was in Ohio, but I love that particular name. There's actually a point called insane asylum. So they measure all those, and they just get the raw measurement, So there's zero is this direction, and then over here we have 20 degrees, and over here we have 70.3 degrees, and over here we have this measurement. And they didn't just measure them. The whole process to measuring them was ridiculously complex. They would actually, they have this giant wheel that sits on it, and they have 3 microscopes. There's a couple different theodolites, but this is one of the bigger ones. 3 different microscopes, and on the wheel they've actually etched degrees, minutes, seconds all the way around it, 360. And they point it one direction. They look at the 3 different microscopes and they write down the measurements from those microscopes. And then they turn it to the other location and they look through the 3 microscopes and they write down the different angles on that microscope. And then they turn it again. They get all their measurements all the way around. And they do the math. So each position had 3 different measurements from the 3 different microscopes. And that gives them the angle for each one. Then they take that whole wheel and they say, well, how many times are we going to do this? Well, we're going to do it 6 times. Okay, so they twist that whole wheel about 1/6 of the way around, and they do the whole set of measurements again. And they twist it again 1/6, and they do the whole set of measurements again, right? They do it 6 times. And the reason why they do that is because when they etched the degrees, minutes, seconds on the theodolite wheel there's tiny little imperfections in it. So when you do all of these measurements, it averages out any errors in them. So one angular measurement might actually be the result of 20 or 50 different individual measurements on one day. And they did it multiple days. So that's what they're doing in these things here. Then they get this whole network. Try not to go too long in this. They get this whole network of triangles. And they have these angles in there, and they put it into this giant set of what they call entangled equations. And even when you're doing this type of precision, you know that there's a possibility that these different places don't all meet up because there's lots of triangles. So any one point is aimed at from 5, 6, 7 different positions. And all of those must sum up to 360 from that position. And all of them pointing to it must sum up to things from each of those positions. They put these all together into this big entangled equation mess that we could write today in software to do it, in tenths of a second. But then they had to do it by hand on paper. And so it was very tedious. And there's different methodologies in this book from T.W. Wright from a couple decades prior to it that talks about how to do it. And in the end, they have these adjusted angles so that the different points more accurately meet. So when you look at the actual raw measurement, you're looking at just what was taken off of the theodolite, and then you apply the entangled formulas, the entangled equations, and then that's the one where it always has spherical excess. The important thing is none of these entangled equations includes any assumption about the radius of the Earth.
Right, they're just angle measurements.
Yes. So sorry that was long, but necessarily long to get a good understanding of it.
No, that's great. That means that, because I know a lot of people would probably just assume that, oh, well, these numbers you're presenting are just one measurement. Where's your repeat measurements? Blah, 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 blah. How many did you throw out? Yada, yada, yada. So you kind of just addressed all that in the one go. So I do appreciate it. And I know that a lot of people, it's really funny. A lot of ad homs in the chat, right? So it's incredible. My main purpose for doing these types of debates is not for the Maury drama, but to actually learn something. So that is why I'm cordial. That's why I ask a whole bunch of questions, and why I do acknowledge that I'm not an expert really in any of these fields. It is something that I'm just learning. So I do appreciate you taking the time, and I do appreciate the audience who is cordial as well. But I do not mind a little bit of fire. So with all that being said, when it comes to the spherical access measurements, you said that when you get the really, really good ones, basically, long story short, that they always have spherical access. How much spherical access are we talking? What's the greatest example?
The largest. All right. So I actually have every single triangle that was in that survey has been entered in by hand by a group of people, and there's 700 some triangles. So I have a spreadsheet with like 60 sheets on it, I think, that has everything in it. Those are seen. So there's both horizontal and vertical angles in it. So,
Ad hominem requires a container. I'm sorry. That's the comment of the night, dude.
oh, good old Darth. Okay, there it is. There is, I think, yes. 2,195 rows in this particular table, but it's 3 rows per triangle. The largest spherical excess. I didn't put together I didn't fit. We're in the process of verifying all of the numbers, but the largest spherical excess is. I have to go off of memory. More than a degree.
Total? More than an arc second.
No, more than a total degree. I can get a better. No, I can't. I can't sync it live because my Dropbox.
I guess that means you lose. Earth is flat, and
I don't know if it works that way. It's in here. So on my website, mc2.net/se is a link to the view-only version of this particular spreadsheet. If you want to look at it, if anybody's interested. So there it is. All right, so spherical excess, largest one, 16 arc 40. There we go. We have 57 arc seconds. So that's about an arc minute. So about a 60th of a degree. That might be the largest one. That's between Mount Lola, Mount Diablo, and Mount Helena. So it's in the Rocky Mountains.
Okay. So that's all the Rocky. I'm sorry, I'm not familiar with all the mountain ranges. I mean, I knew some of them, but yeah. How big is the triangle? Like America size, or we're talking
America size? No, it's the internal. Let's see, we've got 107 kilometers, 213 kilometers, 218 kilometers are the three sides. So they're long triangles.
I'm sorry, I was a little distracted by this other person, Matt Klein, saying stop playing kid games like Fortnite and play a real game like Kerbal Space Program. That's funny. Do you get kills in Kerbal Space Program?
Yeah, you can blow up your rocket.
Where's my battle pass? I'm just kidding.
I,
You really shouldn't play. You really shouldn't play video games, but it was good. It was good for the point, and I do think it's funny that it's like, well, it's only because it's limited. Was your answer is like because the size of the Fortnite map was so limited, that's why we're able to see the drop. But it's like you're not able, even on the ground, like you can see a little bit, and you're not. I mean, you're not seeing all the way across it to see it. It drops. So I mean, I'm curious of why we can see it drop in the real world, like we do in the real world, but on a completely flat stationary map.
So yeah, PG Tony says there's a direct relationship between spherical excess and area. And so if you do go to my website, anybody at mctoon.net/SE, I actually give the formula to give the radius of the Earth if you know one of the sides and the three angles. So if that's all you know is one of the sides and three angles, you can know the radius of the Earth within that particular triangle. And I actually, as part of this this exercise, apply that, and guess what? We get the same radius across them all. So the problem is you don't have any measurements of flatness.
Well, none that anybody would accept, right? And that's why I'm not falling for any of the goats of like, give us your flat Earth evidence. I know what you guys want. You want like something new to to deal with. Same thing that we want. We want new globe Earth arguments to debate as well. But unfortunately, until we figure out what's like going to be actually accepted, which is actually where I was about to go to, as far as like falsification, if we were going to set something up to actually falsify the claim, what could be the parameters that would be actually accepted? Because we've tried long distance observation, we've tried mirror flashes, we've tried lasers, we've tried long distance photography.
Those are all the same type of experiment.
We're all trying to, well, again, we're dealing with the direct issue of the Earth curvature, right? So I mean, I'm not sure why we would test something other than trying to measure that when trying to prove that. So yes, the examples that I just named were all attempts to measure sphericity.
But they're all the same thing. It's all optically looking at something that's very much affected by vertical
well,
refraction.
if you think about it, MC Toon, I mean, if we're just being completely fair, that's the exact same thing that was used for geodetic surveying. I mean, we're taking optics and we're making calculations based off of the measurement of angles that we're seeing.
But those are mostly horizontal angles.
We assume.
No, we don't assume. We can actually look at them. I have 2,100 lines of a spreadsheet that are horizontal angles.
So, and this is kind of the issue that we had to disagree on. The reason why we're back to this point is because, again, we're finding out, and this is something that's kind of new. It's not something that's been super well studied, but we're now discovering that the way that our assumptions on how the light travels to our eyes and the way that we're perceiving them, it used to be that we were seeing in this pure Euclidean geometry. And again,
you're going back to the same gleam stuff. It's just human imperfection in our subjective analysis of it. That's not what a theodolite sees.
You took a local example, and what you didn't even really give like the hardcore parameters, like how far away they were and how much access they were seeing. And it should be obvious that when we're talking about greater distances, the way that hyperbolic space works is the greater the distance, the further away something gets, the more affected, the more spherical access you're going to observe. And this is not just true side to side. It's also true, with things up and down when we're taking a, vertical measurement versus a horizontal measurement. So things are still going to be affected in that way. And you have just asserted
but
that
just a second.
the analyte just takes the true measurement.
But the problem is that the paper that Whitsitt presented, direct measurements of the curvature of visual space, spherical excess was in the nearest ones. The farthest away ones had the opposite. Had less than 180 degrees in the triangles that they perceptively measured. So it was the opposite of that.
Well, I'll have to look at that. I don't have a rebuttal to that right now.
Okay. All right. Do you mind if you get some heat from the audience?
Yeah, go for it. Fire away.
All right. I don't, so, I don't read stuff that's just over the top. People know that. So, and Marissa, I might even read Marissa's because she was in here trolling with super chats. The crazy Marissa. She's funny though. Peachy Tony says, so is there a lump sum payment scheme we could negotiate so we do not have to listen to Flirps? Tony, you could just go somewhere else. Tony, there's lots of cute cat videos. If you want, I can send you some. So, all right, Tony does then, he says, PhD Tony says, Dumpy Creek, Australia, Goijo, Kenya, Portozuelo, Chile, and the point 66 degrees north, 126.1 degrees west, Canada, are all about 12,170 kilometers apart. 4 equidistant points is impossible if the Earth is planar. Conclusion, Earth is not planar.
So he claimed 4 equidistant points on Earth are impossible on a plane?
Yes, well, so the problem is you can take any flat Earth map and you can just take a flat Earth with nothing on it, right? And then you just take cities and you say, well, this city is this far from this city, and this city is this far from this city, and this city is this, right? And you can make a triangle with 3. That'll work on any surface at all, actually. Concave, saddle, some undulating thing. But as soon as you get a 4th point in there, a 4th city, then it requires that the surface of the Earth be accurately known, at least within the vicinity of these points. So, and that's what Tiger Dan did. If you're familiar with Tiger Dan, he tried to actually use distance measurements between points on a flat Earth map, and he moved them all around. He did this on his computer. And in the end, he found out that he needed to have multiple Australias in order to make it work. And he's like, I keep trying, I'm going to keep moving it here, And he couldn't make it work. And in the end, he's like, I can't make it work. I don't think the Earth is flat anymore. And he left flat Earth. He's still doing videos. I actually sent him a message a while ago. I said, hey, would you come talk to me? He said, no, he's not doing flat Earth stuff anymore. So Tony's point is that those 4 points don't work on any particular flat Earth map at all. So I haven't verified it. I'll just take it as it is.
That's pretty much where I'd have to be at it right now. I'm not a disingenuous person. If someone claims that there's evidence for something, I'm not just going to dismiss it right on its face entirely. If it seems possible, then obviously let's take a look at it and put our thinking caps on. Give it the old college try, as they say.
Did you go to college?
For a little bit.
Yeah. What'd you study?
So I was in there for business finance, and I was on a wrestling scholarship, but I didn't finish it because they were charging an arm and a leg, and I got injured. They didn't want to continue my scholarship.
Oh, that stinks.
It was a pre-existing injury that I kind of kept under wraps. So I mean, I guess I have myself to blame, but what are you gonna do?
You didn't tell him?
I wanted to get in.
Oh, I suppose I wrestled in high school. It was one of the sports I did.
Oh, nice, dude. That's awesome.
I was no good.
It's a tough sport, man.
I
It's
was
not for
no
everyone.
good. I didn't. I'm like, I'm just gonna do it to do a sport. So
That is not the sport that you do to just do a sport.
yeah, you make a good point. Tell 16-year-old me. Uh,
I was the person who was in charge of, and I don't say this to like be a bragger or anything like that, but when I was 100%, me and a few other people were the people who were designed to just like train extra hard on the new people. That way, we didn't get uh, the people like you who just wanted to be a part of a sport. We can't have you guys ending up on the varsity team and messing up
oh,
states.
I was definitely not on the varsity team. All right. So Stringer News One says I was a big fan of the old computer, and my old computer would get so hot that I had to crank up the fans, or it would freeze sometimes. Not freeze, like shut itself off. But this new one here, you can see the scroll going across the bottom. It's nice and smooth. I'm getting full 30 frames a second.
Heck yeah, dude, looks good.
Yeah. Dave Kircher says, thank Titicaca. It's Toonsday. Hey, what's your favorite South American lake?
Me,
Yeah.
my favorite South American lake.
Yes.
I don't have one.
Mine is Lake Titicaca. You see? Yeah. All right, let's see. Marissa comes in with, since you won't address me privately, block my post on debate, and refuse to correct the record, will you read and answer all the super chats out loud? Maybe. Marissa sent me a list of 5 things. Every one of them was wrong. She's like, and what are you going to do about that? Like, one of them was claiming that Sirius is the only binary star, when that's totally wrong. So, and like, I have to, for some reason, she thinks that I have to be the one to show, to support her point. Anyway, he who divides by zero says, I would pay good money to watch a debate between a flurf and a concave moderated by a round earther.
Concave gets slapped around, dude.
I tell you that they are the redheaded stepchild of this debate here, aren't they?
They get no love. They get no love at all.
But you know, they're kind and gentle sometimes. They think, you know, there's a disproportionate number of concavers that think they're Jesus, or they have a Messiah complex. Do you know that?
That is hilarious. I've never met somebody who had a
Yeah,
God complex.
Lord Stephen Christ is the most well-known concaver. He thought he was Jesus. He was replaced by somebody calling himself, I forgot his name. He thought he was Jesus. Joshua Valerio, he thought he was Jesus. He went by Zenith Atlas. Sam, what's Sam's last name? He's in England. He thinks he's Jesus.
Well, I will say the hollow earthers need to understand that hollow earth can only work if the earth is a flat topographical plane with layers. Can't work if it's a ball.
What? You mean
Gravity-
hollow or concave? Because they're
hollow.
different.
Hollow earth.
But hollow earthers think the earth is a sphere and Godzilla lives inside.
Yeah, but you know, if the earth was hollow and earth was a sphere and you guys were right about all the gravity nonsense, then it would just collapse in on itself.
Oh yeah, hollow doesn't work for gravity.
No, but it would work for a flat earth. So we're on the same side, you guys.
All right. Oh my goodness. 1, 2, 3, 4, 5, 6, 7 from 8, 9, 10, 11 in a row from Marissa.
Super chats?
Yes.
The love is real.
She's Marissa. Thank you for that. I appreciate it. I'll read them. Here we go. She says, is it possible to divide by zero? If you must eventually divide by zero as you approach from either side of infinite limits, are infinite limits possible? That's what calculus is for. Marissa says, is Sirius the only binary star made of 2 components? Other part of systems from your own source? Can you show those sources? Explain otherwise. Your claim is Sirius is the only binary star. So you're going to have to show that. Again, she says, is Sirius the only binary star? She said the same one twice in a row. 3 times in a row.
What if it was a glitch? Then I'd feel bad. Bank account's just getting drained.
Wow. Then she says, have you made a rainbow inside with just water and light? What causes the opposite color pattern if no difference in water angle refraction on the globe? People have made rainbows inside. And she just says nuh-uh to them. So whatever.
Well, they have mirrors inside.
Seriously. I mean, what do you say about rainbows inside and the dome?
I'm not really a domer.
Okay.
I mean, it's possible, I suppose, but I don't have any. Same with the sun, right? I don't have a way to verify either of it, and it's just as easy for me to believe that there is a barrier as there is to believe that there's a downward bias. So regardless of what that is causing that downward bias, it's not too hard to conceive that it would pull the gases down. So I just try to stay away from that claim for the most part. But if someone else brings up gas pressure, then I do get curious about the gas pressure without a full container bit.
You get curious about it?
Yeah, because the only real evidence towards it being able to exist contained without the container is the invocation of the downward bias, which, I mean, we do have things like helium and other gases that seem to defy this by going up. But I think that's just the issue with how you see it, because the other way to see it is that all these gases are in fact just sitting on top of other gases.
But when you remove the air, helium goes down. You put it in a balloon, it'll fall.
Right. Yeah, you just let it get well, actually, if you put it in a balloon, doesn't it equalize out? Doesn't the helium drift out and regular air kind of a little bit?
No, if you put a balloon in a chamber and you evacuate the air, the helium balloon falls.
Yeah, I agree with you.
So there's still a downward bias. But all right. Marissa says, does light travel in straight lines to make shadows? Does everyone's light go east-west? Does a shadow made always point opposite of the light source? Well, in general, light travels straight, but of course things can bend it, right? I don't understand her point. She's so wacky on this, right? This is the map she kind of seems to like. So if Marissa, if the sun's there, right, that dot, and an observer in South America there, down there, midday, will see the shadow facing directly south. I don't know what your problem is. She must think that the sun goes around the outside perimeter. I don't know. She's out there. I don't know why she even says that. Like, there's a billion people that live south of the equator, and they all see south-facing shadows. Let's see. She says again, did you allow someone to make a video using a compass that admits the direction dial can be turned instead of a compass phone app the dial cannot turn? Do you think it's a scientific example? Do you know that good compasses have this dial on it that you can turn?
Yeah.
I think Marissa doesn't, right? So you take your declination. You actually, on the back here, you can input your declination. It actually clicks. Let me see if I can. It's not a loud click. It actually clicks as you turn it. So you can set your declination, and then north will be north once you set your declination. I think she missed that. She wants me to address it. I already did. Why are my comments not allowed to stay on her debate link? What part is offensive to you? Rainbow/shadow production or sonoluminescence? What is the physical location of any/all your poles? What evidence is that location is opposed to elsewhere since the foundation of a globe? Any or all of your poles. We went over it. All right.
I think that just to kind of lighten it a little bit, I think it is interesting when we say things like the stars can be solemn luminescence, which it does appear like they could be something like that. Just, if you just look at the star itself, but we do have to be careful when engaging with Globers like that, because they could easily say, well, where is the jar? And then our hands are tied.
Yeah. Well, I did a thing. You see the stars twinkling, right? And I did a thing for Mikey Smith in a video I did on him a couple weeks ago, where I took a P1000 and I zoomed in across my house, all the way across my house, to a light that was on my table, and I put a candle underneath where the camera was looking, and it made it all wavy. It wasn't a sonoluminescent light source. It was just the charger on a cell phone or a USB charger. And then it was out of focus. So it looked like the stars that people get with their P1000. But then I took out the candle and I focused the lens, and you could see the light real easily. So
yeah, there's lots of ways that you can make things appear like stars. So
yeah, and so it was. Mikey Smith's point was that's the only possible explanation. I said, well, here's another one. All right, Sial 8ERO2 says, are you paid by contract to lie by deceptive means and deny unchangeable facts? Will light/water change? Will you stop lying to your audience? Well, I was paid by you just now. So that person paid $5 to ask that question. Thank you for that. All right. Al Trucker says he doesn't get it because he's out of blinks. People were asking you to blink. Did you catch that?
I can blink.
I don't know. There you go. All right. Peachy Tony says Eratosthenes knew Earth was spheroidal from Earth's shadow on the moon, so he only needed 2 points.
That's a huge begging the question, dude.
I disagree.
To assert. Okay, think about it in the perspective of like in Eratosthenes' day. All right, we have all the other cosmologies from all the other cultures and people being the flat cosmology. So, why would they assume that what purpose would make them assume that the shadow on the moon is the Earth in the first place? It's for them to work backwards and then say, well, that's the Earth's shadow, so therefore we know we're a sphere, so therefore we know this assumption works for two observers.
So yeah, and in Eratosthenes' time, it was well established that the Earth was a sphere through other things. And there's the other guys whose names start with Air. You got Aristarchus and Aristotle, who had they get credit for it. It could have, who knows if it was them or somebody else. But they talked about things like the shadow of the moon, the fact that the sun sets, all sorts of things that people knew at the time that led them to believe that the Earth was a sphere, and though they had concluded it right by then. So that was well established at the time. It wasn't him trying to prove anything.
Well, Aristotle, when Aristotle came out with that, I mean, actually, let me ask it instead of just asserting something, so I don't sound dumb, right? When did the forward for Aristotle, or is that Copernicus? Who has the forward where they're like, we know that there's no way to prove, there's no way basically to prove this, but let us assert this or have this be accepted in with the other models of cosmology. This was before heliocentrism was like heavily accepted. Was this Copernicus or Aristotle?
Well, up until the 15, 16, 1700s area, the specific date I don't know. The position was that the Earth was a sphere, but that it was at the center of the universe. So it was Copernicus, Galileo, and Kepler and other people around that time that came with the Earth being not at the center, but the sun being at the center. So that's a whole different thing than whether or not the Earth is a sphere. So that had been established somewhere around 500 BC is the earliest that we can trace back.
How did they
To,
establish it? Besides, because it wasn't Eratosthenes.
uh, yeah, hold on. I have a list. Pythagoras was the first. So, all right. The really super catchy thing. It's a work in progress page. I'll send it to you. It's meant to be a list of different people and their writings about the shape of the Earth. So, and if you look at it, not a lot of these links are filled out yet. So I don't like, for example, 495 Pythagoras. I don't have the actual measurement or the actual written stuff that he wrote. 320 BC, you got Aristarchus. 322, you've got Aristotle. 300 BC, you've got Euclid. So Euclid wrote the phenomena. And I have a copy of it. Here it is. Euclid's Phenomena, where he wrote about spherical trigonometry and about the Earth's shape being a sphere. So 300 BC.
But we don't know how, admittedly, not right in front of us, we don't have exactly how that was determined. I thought that they determined it just by ships going over the horizon.
That was one. And I do think that Aristotle mentioned that. So, like I said, I don't have the links to these yet. So, people, if you have the links, email them to me or send me a DM somewhere. So, I do have like the writing, the Archimedes, the Sand Reckoner, who gave credit to Aristarchus, but it was about 100 years prior, so he didn't know him by hand, personally. But I do have a link to that particular thing. But then you got 195 BC, so about 200 BC, about 300 years after Pythagoras, Eratosthenes did his measurements. So he's 300 years after people knew that the Earth was a sphere. So it wasn't something in contention at the time. So, but that's how, to answer the question, that's how. So.
Yeah, I've seen that. I always ask how, and I know it seems like counterintuitive, but basically what people need to understand is what I'm attempting to do is I'm attempting to establish first principles, and regardless of what it is that anybody in particular in the mainstream believes, right? If you truly wanted to convince somebody from my side of the fence, what you would have to do is just that, establish the first principles, which is just the ones with the absolute least amount of assumptions possible.
Sure. And
So
all of this historical stuff doesn't matter. We can all do it ourselves right now. I did the Eratosthenes type measurement myself 4 times. He did it once, accepting that he did it at all. He did it only once. I did it 4 times. I did it with multiple other people. Over the course of the 4 times that I did it with there's probably 20 or 30 different people that did it. It's not hard to do. You could do it any day of the year yourself. Because we know now real accurately where the sun is at any time, right? The GP of the sun is well established.
Well, I think we kind of went in some circles, and I know exactly where I want to focus my next little area of study. So I definitely appreciate the conversation. It's been very educational and cordial. So it is getting a little late on my end. So how many more questions do we have from the audience?
I have quite a few.
All right, let's go then. Let's get it.
Let's get it. All right, let's go fast. Gary IOW says, has it been 16 months? He's been a member for that long. PG Tony says, your guess is wrong. The angle to a celestial object increased linearly on a globe, not on a plane. It sounds like he doesn't understand trigonometry. I think in your defense, you were talking about the sunset and sunrise, not the latter,
I was actually specifically talking about the relationship between the shadows. And I may have mixed them up. That is possible. But basically, what I was asserting was that the shadows on the plane Earth would have a linear relationship, meaning as the sun moved away, you would see a linear relationship between the growth of the shadows versus the spherical shape. You would see an exponential, meaning the shadow length would get even greater than just the standard pattern of the linear relationship.
Yeah, like at sunrise and sunset, right?
Right. So
Yeah,
in other words, what you would see is like if you put a value to it, it's like we'd see the shadow 5 feet, and then it'd be 5 feet even greater and 5 feet even greater. But on a sphere, it would be 5 feet, 7 feet, 10 feet, so on and so forth.
Yeah. Well, I'll say you I don't know offhand if it would be exponential on a globe, but it would grow fast. But on flat Earth with this particular map, it wouldn't be linear. It would be a trigonometric relationship, because you'd always have, it's doing a circle over your head is the common claim, and so the angle to that, the distance to that, the angular elevation would be based on trigonometry, not linear.
I guess I'm confused on like what the difference is between a linear relationship and a trigonometric relationship.
All right, maybe for a different time.
Trigonometric obviously is going to deal with triangles. Linear, are we just dealing with straight lines?
Well, if it were linear, then when you double the distance, every time you double you increase. Honestly, if you went from 10 feet to 20 feet, it would change by a certain amount. When you went to 30 feet, it changed by the same amount. If you went to 40 feet, it changed by the same amount again.
Right.
That would be linear. If the sun was circling overhead, the distance, thus the angle, would change in probably an inverse tangent relationship, or definitely in an inverse tangent relationship.
You have to forgive me. I don't.
Or arctangent. Yes,
like
but
shadow would form like a circle, like a sundial, or am I misunderstanding?
Well, yeah. I mean, the sun could never set if the Earth were flat. So,
I mean, I disagree, but we'll just go back. We'll just go back into
the perspective. All right. Let's keep going here. Doubtful Form says wasn't trying to prove the shape, just the radius. That was about Eratosthenes. Thank you for that. Pat the Chat said, just when I thought we had run out of flirts to educate, a new class has taken the misunderstanding of science mantle and started sprinting with it. I don't think that you're quite there. I'm not going to put you in the camp of Mikey Smith.
That's funny.
Do you know Mikey Smith?
I very familiar. Not very, very familiar, but I'm familiar.
You have kids. Are you familiar with Caillou, the cartoon Caillou?
Yeah.
He's basically Caillou. Go watch him. You tell me he's not. GLE G81 for 50 euros says, thank you, McToon. Thank you very much. GLE G81. Call me McToon. I love it. Mantle 311 says 30 minutes in, where are the measurements of flatness? Somebody asked me a while ago, how would you measure flatness? As if you couldn't, right? You could. You establish a flat thing and then you measure the deviation from it. And if after, 10 miles, 20 miles, 100 miles, the deviation is within the same margin of error, basically no variation, then that's a measurement of flatness. You'd have to account for variables, though. Mark Beiser is a member at Buzz Aldrin. Are you a big fan of Buzz Aldrin? Are you familiar with the top left competition?
The top left competition?
Yes.
That's the one that you have on your page, right?
Yes. So we just finished it last week, and the winner was Cece from Westchester County. You know Cece?
I don't.
You don't? Oh, you are missing out. CC1, and I'm going to send him an apron. So I have a custom made apron on Teespring that I'm going to send him. So I haven't sent it though. I just said, thanks for reminding me, Mr. Tomato. Ms. Tomato, sorry. Sorry. Zoomy. How about that, Zoomy? How did CC like his apron? I think if y'all sent it, he'd have made a video on it. So it takes a couple weeks to make and have a thing from Teespring sent. So RT96 is still waiting for those measurements, TT. Nothing yet. Stringer News 1 as that's hey. Careful, Stringer News 1. Stuart Christmas says, I hate to agree with Flurfs, but they have something right. The sun is indeed small and local. Small because as stars go, it's average sized at best, but on the lower side. Local to our solar system by definition. Score 1, Flurfs. There you go.
Heck yeah, got it.
He who divides by zeros. I don't know if there's, I mean, an hour in, still waiting for measurements, TT. I don't know if I'm going to get a whole lot.
Well, it'll be quicker that way.
Yeah.
Yeah, like I said, the measurements thing is like I have the same measurements that have probably been presented. I mean, I know you've debated Witsit before. I know you've debated quite a few flat earthers. So I'm not going to be able to present anything that has gone through the rigors of, okay, here's the refraction check. Here is the basically all the checks. I haven't done it myself personally. And the ones that have been done for one reason or another always have something wrong with them, according to the public. So what are you going to do until I have my own, which is coming soon? You can get some, I believe I can get it done with, at Florida. I'm in Florida. There's tons of areas of flatness. We're in one of the flattest states, and you can do mirror flashes. So I think that's like one of the cheapest ways to do it. It's just before I even do the mirror flash, and it's a great thing that I have you here, McTunes. So I'm glad that I remembered this. MC Tune, sorry. But it was when it comes to the mirror flash observations, the way that you can see the mirror flash, right, is because the flash is like the glare on the lens, right? It's not like literal flashing. You're seeing a point that's so bright that it's now causing lens flare. Am I wrong on that? Or are we literally seeing a flash from outside the radius of the mirror?
Well, because you're reflecting the sun, right? So it's affected by the same things. Refraction is affecting it the same. And if you're doing it over water and you're doing it on a day that has high refractive index, or coefficient of refraction is a more proper term, then you're going to have it refracting more. And you will be able to see it from farther. But yeah, it'll appear big on the camera because it's significantly brighter than things around it. But I don't think that's really the issue.
Okay, so as long as we pick a location that is far enough that it wouldn't matter what the refraction index, what the named refraction index is for that day. So I'm just working out the experiment so where we can actually all accept it. I go out to the bay. We go and we pick a spot of a location that we know is at least like 15 plus miles. There's several of them here in Florida. And we do a mirror flash observation at the shore. And we just take all the factors into consideration. If we are able to still see the mirror flash, despite proving out mathematically and with what's actually labeled for that day, what's been measured for that day, if we then still see that mirror flash, would that then be positive evidence towards the flat earth claim?
So you need to account for the variables, right? So this is a NIST certified thermometer, and you can get these. You don't have to use a NIST certified one, but Industrial Nerd sent me this because they had it at work. And you want to measure the vertical temperature gradient. If you really want to control for variables, you have to do that. So down on the water, ideally, you'd measure right above the water, measure half a meter up, a full meter up, every half meter maybe as high as you can reach, measure the vertical temperature gradient. Do it on both sides. That's one way to control for refraction. And knowing that vertical temperature gradient, then we can know how much the coefficient of refraction is within a certain
May I interrupt just
area.
a moment?
Yeah.
Just based on the thing that you said about when we take the measurements on one side of the lake and then the measurements on the other side, or like ocean, whatever the heck, body of water.
Yeah.
Um, I've heard this actually criticized before because the FE core actually did some refractive index measurements, temperature measurements when they did the laser experiment, and they did it on both sides of the lake. And I've been told that because they didn't do it on every point, every meter basically over that lake, that they couldn't have gotten it accurate, and that just doing it on both sides of the lake was going to give them an inaccurate result.
So they only did it on one side. Oh, I'm sorry, they did do it on both sides. The problem is that they didn't apply the coefficient of refraction. They actually just did a from one side to the other, as if that there was a vertical temperature gradient instead of a horizontal temperature gradient. That was their error. They did it wrong. When I actually did the application of the vertical temperature gradient, it gives a coefficient of refraction of more than 1. And a coefficient of refraction of +1 means that the radius of the arc of the light will be greater or equal to the previously measured radius of the Earth. So you need to have it less than that. And so when you do things in certain conditions, people like to do it at night. They like to do it over water. They like to do it on a nice clear day.
Before you move out on too far, I just want to kind of work backwards for a moment. And dang it, you kind of said too many things now. I'm trying to remember it. It was the no, I lost it. Go on. I'm sorry, I interrupted.
Okay. Well, anyway, when I did the application of the coefficient of refraction from their measurements, it totally confirmed the globe. So I accepted their vertical temperature gradient. There wasn't a problem with it, right? If you want to be super precise, so that you could actually somehow, try to output the radius of the Earth or the amount of curvature between them, then yeah, you'd want to increase the amount of data points. But if their only intention was to try to falsify the globe, but they confirmed the globe.
Oh, I kind of I have to look at it again. I think it was a little inconclusive, considering that they apparently didn't do it right. But again, that's just what I've been told by other globers. When I look at it, I don't really see all the things that you guys are talking about, but I also accept that I learned more every day. So I know more today than I did when I first looked at it. So I'm willing to go take another look and see, exactly if what you're saying is accurate about them not measuring the correct refraction and whatnot. But it seems like, and again, I know that we can just say, well, they're just trying to falsify the claim. I agree that they are trying to falsify it. And the best way to do that would be to take in all the variables as effectively and efficiently as possible. That way there is no wiggle room, right? When you show the proof, you want it to be damning, right? You don't want somebody to be able to, oh yeah, but you obviously didn't take into account this simple thing over here. So boom.
Well, there's no way to take everything into account. There's no such thing as a perfect measurement.
That's true.
So they're not going to ever be able to take into account every single thing to get zero margin of error.
You say inconclusive is the word for oops, we proved the globe. No, they saw them. They actually succeeded in seeing the observation. So, I mean, if we wanted to accept it as proof of anything, then we could accept it as proof towards the fact that the Earth is not curving. However, because they apparently didn't do the variables right, the best we can conclude is that it's inconclusive. So
I disagree. I thought that they're the only. There's one or two others that I've seen where flat earthers measured the vertical temperature gradient. And Charlie in the chat says no, FE core did not measure the vertical temperature gradient. They did. On experiments 5, 6, and 7, they have photographs of the actual thermometer that they used and the elevation above the water that they took the measurement.
So you can disagree with what they find, but don't strawman the the experiment.
Yeah, no, I think it's a fantastic experiment because it shows that the Earth is a globe. All right, let's keep going.
Yeah, go ahead.
He who divides by zero says, though Tribune doesn't seem to be able to make a coherent point or argument, I have to give him props for being respectful and polite. There you go.
Yeah, I'm not really making a whole bunch of arguments right now. I'm more inquiring than anything.
Now, you like to host debates. I
do.
So if and a lot of the time flat earthers they don't won't come on here and talk to me for this is how I like to talk to people. But would you host?
Yeah, absolutely.
Okay. Well, especially on TikTok, right? If somebody insists on having a flat earther host, I'll come to you.
Yeah, I have it in really good, and even with the Globers too. Most of the ones that I talk to agree that I'm very respectful, I'm very fair, and I won't hold the moderation out on the flat earthers. I've actually noticed that a lot of the time, especially on TikTok, there is a lot of bad flat earthers. Ones that just always fighting for the mic, because it is true that a lot of us feel like we're that special boy, with the special info. So you have to check your own ego at the door, and and engage in let people engage in the conversation.
Well, hey, self what's the word I'm looking for? Evaluation is good. Thank you. I'm glad for that. All right. Pat the chat says you can question the vast amount of evidence for the globe. Pick any distance to move your goalposts. You will provide until you provide positive evidence for flat Earth. You still be no closer than you are now.
I mean, you can feel that way. I would say, and I know that there's disagreement on this, but I would say that lack of measurement of a curvature would be evidence for flatness.
So would you say then that a measurement of curvature would then falsify that whole class of claim?
Yeah.
Because I have them.
Well, you have indirect, or what I would classify as indirect. You have spherical excess. You have inferences, but there's not. I would say there's not a direct measurement.
Well, what's a direct measurement then?
So a direct measurement would be like, let's say, although I wouldn't trust, it's kind of nuanced to say this, right? Normally, I wouldn't trust like just data, right? But if we could agree that the technology exists, that we could shoot a radar and get like back a measurement, right? Then that would be a direct measurement of something. However, what we are doing in the case of the globe is we are seeing drop in the distance. We're seeing, we're measuring angles to things in the sky. And then from there, we are inferring the shape of the Earth. We're not actually.
Okay, but you didn't go back to what is a direct measurement?
So a direct measurement would be when you're actually directly measuring the thing. An indirect measurement.
So how would you do that then? How would you directly measure?
For the Earth, I'd probably use like microwave or radar.
But microwave and radar are photons, just like light.
Right, but microwave in particular is less affected by refraction.
Okay.
So, yeah, I would use that.
It's not going to work out for you, though.
It might not, but that's the beauty of doing real science, right? You're okay with falsifying your own claim, and I'm perfectly okay with falsifying the flat Earth claim as well. The problem that I'm noticing that we have is that a lot of the proofs come from, we have government surveys, we have government space programs, basically it comes from a lot of authority. And
I haven't cited those things.
No, you haven't, and that's I'm not saying that you have. I'm saying for the most part, when we're dealing with this type of debate, now you actually do what a lot of people don't do, myself included at this point, which is doing your own mathematics, doing your own experimentation.
Yeah,
which is definitely recommended because then you have your own real world hands-on experience with it.
So you like radar. People have bounced radar off the sun. It took about 980 seconds for the signal to come back.
Actually, well, are you sure about bouncing the radar off the sun? From my understanding, we bounced it off of Venus and then we calculated the distance to the sun.
No,
the sun was so hot that we couldn't get the return.
No, I'm specifically talking about a radar that was bounced off the sun, and it took a certain amount of time to come back. Now they weren't trying to measure the distance to it. Other things they would point to, but the amount of time that it took to come back in these two different experiments, we can use those to determine the distance to it because of the amount of time and how fast radar travels. You said you'd take radar.
Yeah, I mean, I would take radar if we know all the variables in between, right? But do we know the medium, completely for certain between us and the sun?
Yeah, we do.
How do we know?
Because as you go up in elevation, what happens to the air pressure?
It gets less.
It's less and less and less. Yeah. So, and as you get up above a couple hundred kilometers, the amount of air is very, very small.
Sure.
So, and what could cause significant changes in the amount of time that radar bounced between here and the sun? Well, you said already that radar isn't greatly affected by refraction. And you're right, and that's because it's about the speed, right? Refraction is due to a change in speed through the medium. So radar is less affected by that. So in order for something that's not really, really distant to take 980 seconds to go there and back would require that the medium is significantly dense. Really, really dense. Right? Like index of refraction of 1,000 instead of 1.5 dense. Right? There's no materials known. There's no, right? Diamond is one of the highest that are you can see through, and I think it's 2, index of refraction of 2. So anyway, we're going off forever on this.
I actually do, and this is a point that I actually do think is challenging for flat earthers, and that is that basically what we would have to do is we have to assert that there's something else going on with the radar signal, and we don't have verification or proof of anything that would do that, right? So that is something that's like a check against flat earth, let's just be honest. However, we get around that by simply asserting that, well, you don't know you don't know the positive end of it, right? So we're basically claiming the negative of that. Well, you just don't know, so you can't assert to know. But it is a fact that we are getting something, some radar signal back, and anybody with a ham radio can do this. I've seen this done, live
off the moon. Yeah.
So I mean, it's claimed to be off the moon, and it isn't certainly in the direction of the moon, right? So who am I to say? But that is basically our best answer, is that it's either bouncing off of something else or it is going through a dense medium up there that we just don't fully understand. And that is basically all there is to it. But I would also say that even if the moon is, in fact, so many miles up above, and the sun is so many miles up above, what if it is, literally, 98 million miles away, but it's still a flat Earth and we're not in the space vacuum? It's
a whole lot of things wouldn't work though.
Right. But again, we're talking about establishing first principles as opposed to just accepting a model at face value. So, and there's absolutely nothing wrong with that. Somebody mentioned in the comments, is like, if you're going to try to challenge something, challenge science, don't challenge something that's been established for hundreds or even thousands of years. And I would say that statement in itself completely flies in the face of everything that is scientific. Science is constantly challenging itself. And we'll actually find out that when you look at the history of science, the most established, or what were thought to be the most established facts, turned out to be wrong. So science is always evolving and always taking another look at itself. There's nothing wrong with that.
Leslie Rohrer says the index of refraction of diamond is 2.417. What did I say? 2.5?
You're pretty close.
I'm gonna taking him, which I can only take him at his word. He's pretty good. With that specific, I would guess that he might have even looked it up. So there we go. All right, we got the Sun Express says flat Earth confirmed because video game. And then Virillion says I played EVE online, therefore space is real. I played World of Warcraft, and I think it was all flat there too. Gridhog says, "What if all tech depended on science that flat earthers accept?"
What's
tough. What if all tech depended on science that flurfs accept?
If all tech depended on science?
Yeah, all tech.
I mean, we do accept all the terrestrial stuff, right? So, I mean, the only thing we would lose is, I guess, satellite TV. I mean,
well, you wouldn't have your position from this.
yeah, we
Your
absolutely.
GPS wouldn't work.
So GPS actually, I know that
Don't make a claim you can't support.
people want to believe that it's all like it has to come from satellites, but it's definitely 100% possible and even more probable that it's done with ground towers. So,
Oh, dude, don't do that.
I mean, are we
I
going to
flew.
deny? Are
I
we going to
flew,
deny the buoys in the ocean that have this that carry signal?
yes, totally.
This
I
is
I flew I
okay.
flew
Hold on.
from Anchorage to Minneapolis in 2019, and over the Yukon Territory, where people don't live very much, in an airplane at 35,000 feet. I got a solid GPS signal, but I got no cell phone coverage at all. I have a bunch of pictures from there.
That would be probably due to the attenuation of the signal used.
But how did I get a solid GPS signal?
GPS signals are stronger than phone signals. They go farther.
Yeah. Here's the thing, though. These are just transmissions. Anybody can get an antenna and read these transmissions and get the position. In fact, the entire GPS specification is open. You can write your own source, your own code. In fact, there's open source libraries to implement the GPS spec. You can create your own antenna, and you can make it a directional antenna and point it up instead of sideways. All these things are falsifiable. You just have to do it instead of making claims. Right?
Yeah, I mean, it definitely does help.
I've heard this. I've heard it for 5 years. The same claim that you just made, but I've never seen a flat earther actually test it. The library is open source. The code is there. Right? I don't know. I don't know very many flat earthers that are software engineers.
I'm sorry, I was trying to play it off, but you were cutting out a little bit.
I
don't know what exactly.
I don't know of any or many flat earthers that are software engineers. In fact, I can't think of any. There's Gleam, but he knows the Earth is a globe, so he's just a contrarian that likes to argue. All right.
I get that. I totally get that sentiment.
Indie Tiger Sci-Fi Review says you can't get a globe to navigate. You can't use a globe to navigate. In order for a globe to be accurate enough to navigate with, it would have to be hundreds of feet across. True.
Dang.
PhD Tony says, using simple surveying techniques, we can demonstrate that sea level is not flat. Using light, which you won't take, but you will take radar.
I know, right? Well, I would take. Here's the thing, right? So, I would take light if everybody else would take light, but if everybody else won't take it, then obviously that's not going to work.
I'll take light. You have to control for confounding variables, though.
Okay, that's why I came back to the mirror flash experiment. It's like, man, that's something. Hey, you might catch me doing a Jeranism, right? Where I just say interesting, and then you guys will just know.
Oh, the other thing I didn't finish. What were, remember the conditions I said that were the highest index of refraction? Later in the day, after a sunny day, over water. So repeat it, or just choose a day where it'd be good to repeat it, where it's overcast all day, where the water temperature and the air temperature are similar, so that you don't have this big vertical temperature gradient. Measure the actual gradient and see if you can see the same thing on both days, or if there was something happening that changed the conditions that made it possible. So I want to say that before we got too far. Many Karen says, Florida man says Earth is flat. Do you know that Red Pill Philosophy lives in Florida?
I did not know that.
Do you know why I'm bringing up Red Pill Philosophy? Because you look like him.
Do I?
It's the mustache. He had the same mustache. Now, if you could grow it out, get a little wax on there, that might help.
Handlebar it.
PG Tony says, if as the ship slash building moves further away, perspective makes it appear higher, so there will still be some of the ship slash building visible. Have you seen the graphic where it's like, down a tunnel, and it's like things farther that were up high appear lower, and things that are lower appear higher? You've seen that, right? Mm. And that's because that's perspective, brings things all towards that center spot. So the building that's farther away, and this one here, right? The bottom of this building will appear higher than the bottom of this building. That's why only 10 feet is blocked no matter what.
And then the rest of it is compressed?
Well, it's perspective, making it appear smaller with increasing distance. Yeah,
I guess that makes sense. Yeah, if the bottom is rising up at the same rate, then yeah, I guess I could see how that would make sense.
Yeah, and you can look at that by it's too small to see here, but you can look at that by looking at the angles. You can just draw it yourself. You just on a piece of paper do the same thing I did, but have them be farther away from each other, so that when you draw the lines, you can see, oh well, this angle is bigger than this angle because of how far away it is. All right. I think I'm getting close. Professor Parks, PhD, says, if you can't trust any measurement due to distorted vision, how can you trust anything? How do you trust any attempt to correct for hyperbolic vision? That's a good question.
That is a good question. I don't know the answer to that.
Well, in the paper...
Maybe there would be a equation, a transformative equation that could correct for it in some like blanket way.
Well, the thing is, and did you send me the one that you were talking about, the binocular vision one?
I did.
Okay. Okay. I'll have a look at that.
I mean, I wonder if you guys would accept if we just change the names of what you guys are saying. Like when you say that this is spherical access, if we just called it perspective access, and things like that, if you guys would just accept it.
No, I don't think changing the name does anything. It's just semantics.
I think that's what happened with like electrostatics and gravity, though, if I'm not mistaken. But
you're mistaken.
We don't have to go there.
All right. RT96, he's dogging you. He's like 90 minutes in, still waiting on measurements. TT.
I don't know what you want, dude. You won't accept them. I could have the measurements, and I would have, just to play devil's advocate, right? I could have done the experiment myself, been completely genuine about it, taken all the measurements for the refraction, the temperature, all the way across every single foot of every single inch of the observation area, and present that. And at that point, if it proved my point, you would have to say it's fake.
I think you might have an interesting moment, actually.
Interesting moment. That'd be funny. No, that would be interesting, right? Because I mean, I've been doing this since like 2014, when it was really starting to get popular. So, I mean, it would be pretty.
Wait, cool. Hold on a second. 2014?
Yeah. That was when I first saw that Matt Powerland video.
Oh my gosh, yeah, he started in 2010. You see, I don't when I look at the earliest flat earthers, I don't actually include him. So to my knowledge, you've got Stars Are Souls and Mark Braun are the two earliest flat earthers that I know of on YouTube.
Not Stars Are Souls. Man, that's some religious stuff right there.
Well, yeah. An awful lot of flat earthers religious stuff, man.
Oh,
seriously,
kidding.
You know that.
No. They're not religious at all, man.
The number of people that are like, let's talk biblical cosmology. Oh my gosh.
I just think that the biblical cosmology is interesting because, especially for people who kind of like Brian Cox when he stuck his foot in his mouth and he said, nobody in the history of Earth ever believed that the Earth was flat. And I was like, that's just a false statement on its face. And
Yeah,
you look dumb.
that's not true. Yeah. But you know, the ancient civilizations, they thought that generally that the sun went in like tunnels underneath the earth.
Right. Yeah, I remember that. When I'm looking at Egyptian cosmology, they have the sky goddess Nut and the earth god Geb basically forming the enclosed earth system. And then the sun will go out the gate or whatever it's called, and then go into the underworld in the solar boat where they will fight the great serpent Apep, which is the supposed to be the representation of atrophy. So basically, it's a long-winded story about why the sun never appears to age.
Oh. But it explains for them sunset.
Well, yeah, because they
Right.
didn't understand things like refraction and
Well, no, they didn't know.
atmospheric magnification and things like that.
Well, it was simpler than that. They didn't know that nighttime for them was still daytime for somebody else. They couldn't post it on Instagram, you know.
Take a selfie.
Nobody made that yet. Lael says, "Are there non-binary stars?"
What? Yes.
Although
Although it's offensive to try to exclude them.
yes, we accept binary and non-binary stars. Many Karen says, "Does TT belong to the Kaka family?"
No.
I don't know what that is. Like Titicaca?
I'm not in on the joke, so.
And I missed that. I missed them. I missed the joke. Now he's gonna have to tell me, and then I'm gonna feel embarrassed because I missed it. All right, sorry if I missed it. If I didn't understand. Adro BL says, not related to the discussion, but is it just me, or does troubling Tribune look a bit like young Steve Buscemi?
I'll take it as a compliment.
Have you ever gotten that? I can't not see Red Pill Philosophy. I'm just telling you.
I've heard Jim Carrey, although when it was, admittedly, I had less facial hair. I've seen, what was my favorite one? I can't remember the guy's name. It was really funny. Roger something or Rodney something. He's got like suspenders and stuff. It's hilarious. I can't unsee that.
All right, I just got the joke. Your initials are TT, right? If your family was Kaka, you'd be TT Kaka.
I would be part of the Titicaca.
That would be the my favorite South.
My
American
full name would in fact be Titicaca.
There you go. I'm sorry. It would have been funnier if I got it the first time. Tulios is struggling Tribune. Does the theodolite take refraction into account when measuring angles at Lake Titicaca?
Well, if it was going to be an accurate measurement, I'd hope so.
Yeah, definitely. Darren DeBaron says, in regards to live reacting, I'm the guy who spams emojis like he knows how to flick his wrist for long periods. You'll see. In honor of my brief clout, let us spam some hearts and show our love. Thank you, Darren DeBaron.
Sorry, this is hilarious. TT isn't holding a mirror up to his face, admiring himself while talking the way Red Pill Philosophy did. Why would I need a mirror? I'm looking at myself right now on the camera.
Yeah, RPP did like himself an awful lot. His channel, he deleted his channel. Now he built a house out of shipping containers and has a channel talking about that. Nate Walker says, if you live in Florida, take pictures of Cuba from sea level.
And we have limited range of vision, no matter what we live on. So, I mean, what's a diffusion limit, right? Like, what is that?
Well, you wouldn't see a crisp horizon. One or the other. It's one or the other. All right. He who divides by zero says, give us whatever evidence you got, TT. Throw it at us, he says.
I can give you an example that will immediately be called refraction because I've already been here
So,
and done that.
This is a question. All right. The picture that Math Powerland showed you, that's not that's not evidence for anything
No.
about the shape of the Earth. That's just him saying to question things. Fine, question things.
Yeah,
But
for
what
sure.
was it that got you to thinking that the Earth is flat?
That the positive claim that the Earth is actually flat. It was more like a backwards, working backwards. So when you look around, and I know you've heard this one before, when you're taking the path of the least amount of assumptions.
Occam's
I mean,
razor.
sure. When you look around without any mathematics, measurements, or anything at all, you see a flat world, right? The only indications of spherosity are, again, the way that things drop in the distance. That's it. Um, and unless you're using like a specific tool or a theodolite, you wouldn't even see that in the horizon. You would just be looking at the stars, doing, and that was one of the arguments that supposedly convinced Riz Walden, was that the star angles change too much to be a flat plane going directly over us. It has to be spherical, which then at best you could conclude that the sky is spherical. But in any case, I basically started from there, where it's like, okay, let's try to get the actual measurement of the curvature. And again, this is what we get faced with, which is, okay, well, we have these angles that we measured, um, and we have these some base assumption. Again, without the source, it's hard to argue the point, but we have a base assumption of what we expect the Earth to be. We're throwing out all measurements that aren't within 85% of that expectation. And then
Where did you
even with,
get that from, though?
I got to get the source. I'll send it to you, though, within the
Okay.
next day or two.
Because
I'll
that's
find it.
probably just a single thing.
Well,
right?
it was for the, I'm trying to remember the name of it. It is a specific set of geodetic surveys that were done by, I believe, the British government. I'm gonna have to go back and look to get the actual to get the actual source. But
Wow. So, Sin Cleanser is waiting for me. So, Guy Sin Cleanser wants to debate me, and he had chosen 11 p.m. my time, which is coming up real soon. So I really need to kick it into gear here. And then like 4 or 5 hours ago, he's like, "It's got to be right now." I'm like, "Dude, I just pulled into the driveway from camping all weekend." So, all right, all right. I'm gonna have to just finish these. Tim Pryor says 8 billion people on the planet. Every field of science agrees it's a globe. Our evidence is always going to be the same. Flat Earth is still struggling with measurements. C.V. McCullough says Eratosthenes in spherical excess. Come on. Maybe he's a flat earther. Nerd Alert says sorry, but this guy's a Poe.
what is a Poe, by the way?
A Poe would be somebody that's pretending to be a flat earther.
Oh, that'd be super dumb.
And then says he called you MC Toon, not Mac Toon or Mick Toon. No true flat earther would ever do that.
You got me. What can I say?
Leslie Rohrer says, TT, go to any ocean and video a boat heading directly away from shore, showing it does not disappear bottom up and does not reappear if one moves up. Do you have a P1000?
I don't.
No.
If you guys want to send me a bunch of money so I can buy one.
Do you have a telescope?
Not anymore.
Okay. Justin Messenger says, new evidence? How about actual evidence of the flat earth first? Then you can bring up new evidence. And then a smiley face. Chronic Avenger says, the light doesn't travel in hyperbolic space. What we interpret from one part to another part of our vision has a hyperbolic effect. I think it's a good way to say it. That's our personal interpretation. So speaking of Lake Titicaca, Stringer News 1 says Lake Marchiquita tries harder, but it's less fun to say. There you go. People keep super chatting, so if you need to go, it's been 3 hours.
It's 11 o'clock your time now anyway, isn't it?
Yes. So I have another one.
Guys, stop sending him money. He's got another debate.
Wait for the next one. Mr. E-Man says, I love the show MC2 and will watch in full later. Thank you. Just a Messenger says, ask him how many sheep units high the dome is.
Sheep units?
Yes. It's, you've got imperial measurements, miles. You've got metric.
How many sheep? Right.
Kilometer.
I'd say it's about 300,000 sheep high.
Yeah. So 300 kilo sheep lengths. There you go. Thank you for perfect. It's a Rubik's says, no more Cube membership badge. Oh, yeah, you moved on to Grandpa Simpson with sunglasses. Tim Pryor says, spray bottle by a window with the sun coming in through. Rainbow. Magic.
Well, there's two planes of glass there to refract the light, right? So the flat earthers are claiming that you need more than two places to create the rainbow, and that's why they claim the proof is in the dome. But I say that if that's the case, then what about all the other windows and stuff facing the outside? There's other sources to reflect the light that you could then say is making the rainbow. But
how does it go from the water droplet back out through the window to the dome and then back in? Trace the path of light. Earthrise says, mathematically describe a sunset on flat Earth. But maybe we can leave that as homework for later.
I suck at mathematical descriptions, but yeah.
I believe you.
Homework. I believe
you. Industrial Nerd says, SpaghettiOs. Because that's what Flat Earth Caillou says. James Weber says, any questions regarding military issues, I will respond with what I am legally allowed to share. I have a top secret clearance that has expired recently. Does this dude think he knows more than people with actual access to data he could never see?
Ooh, come on my show. Sounds fun.
There you go, James Weber. Do you only do it on TikTok or primarily, or do you also
I'm on all the platforms.
Okay.
I'm actually trying more to grow the YouTube and Rockfin more because, like you said, the TikTok bans are stupid.
Yeah. Well, if people want to get a hold of you, Troubling Tribune on Discord.
Yep, that's the best way. Or if you don't have Discord, you can do Telegram, or you can just email me at troublingtribune@gmail.com.
There you go. All right. We've got this one who types in all caps. Theal802 says, see, Einstein McToon the buffoon wouldn't tell the truth even if you paid him. I don't know why it started with C. Einstein McToon. But C. y'all just paid me to tell the truth. Mr. E-Man coming back says, did we see measurements of flatness today? And the Distributors One says, how about those measurements of flatness? The Rabbit said, if Mikey can sing, why can't MC Toon rap for us? That's because the Geneva Convention has limits on punishment and cruel treatment. Barry Muff. Barry Muff says, Mikey Smith is working on James Webb fake space binoculars, the Flat Earth edition. So Mikey Smith bought the biggest binoculars made. They're I mean, it's off the screen here. They're giant. They're like 2 or 3 feet long, and they're so big you can't hold them. I don't know why he wants binoculars instead of a telescope.
I don't know.
Charlie Welch says, SpaghettiOs. And Titicaca. That's again the Mikey Smith song. So I made a song for Mikey Smith. He sang. Ableist says, why don't flat earthers simply crowdfund, chart a plane or ship and either go around the equator or the poles because you don't want the truth?
I'm planning it right now, fundraising. If you guys want to donate so that I can go debunk it or verify it, then my Cash App is Cash App Mr. Tribune.
There you go. King Cruz says, Loon, I'm still waiting on my book. I owe him a book. I have to send it. I keep forgetting. Leslie Rohrer says, oh, geez, it jumped. Hold on. says Whitsitt has never presented any evidence at all. It's sad but true. NA, wait. It says NA, are you really sending something? How about my cube? So this cube belongs to NA, and a book belongs to King Crew. I haven't sent them. All right, now we mentioned this before, so we finally get to this from Patrick Butler. What did I call this?
That's a 10-foot wave.
But what I gave it a funny name. I called it a water mountain. And that's because Patrick Butler says that there are water mountains that cause things to be obstructed bottom up. There you go. So he says, Patrick Butler says, does he believe in water mountains?
In water mountains? I think there's only one. Look, there's only one side that believes in huge humps of water between two observers, and that's the globe side.
No, he says that's what causes bottom up obstruction. Like you said, it's waves, but he goes all out. He says it's water mountains. All right. David Dorinzo says amateurs can bounce radar off the moon too. CV McCullough says radar and MW, milliwatt. Microwave. Radar and microwave are used daily to the same result. Hint, it's not flat. I don't think you might want to back off that claim. That you'd accept it. Gary Little says 1954, TV in the middle of the United States, thousands of transmitter broadcasting 50,000 kilowatts of power. The only way to separate them was curvature.
It's the only possible explanation.
Yep. Patrick Butler says, do radio waves bounce off the ionosphere?
The ionosphere? Do you know how the ionosphere was even discovered?
Yes.
No, you do. I was asking them. They probably don't.
Oh, they've heard me talk about it, so I think a lot of them probably do.
Yeah. I like the ionosphere because it's a classic example of ad hocing.
Yeah, at first they're like, propose this. That's science, though. You have a hypothesis. You can get it from anywhere you want. You could have a dream about it. Like, I forgot the name of the guy that figured out the shape of a benzene ring. He had a dream that it was in a circle. The dream was that a snake was eating its own tail. And he's like, what if the benzene ring, 6 carbons, is in a circle? That was his hypothesis. Then they tested it. Like, hey, that works. Caucasian Sensation comes in with a bit of a hard hitter. He says, the ego and audacity of all uneducated flirts disproving scientific advancements is asinine. Says, there you go.
I can easily just say that, for somebody to deny all the good that Christianity has done in the world and all the good things that Jesus has done in our lives in the background. And we obviously know this is true because all the preachers and priests and part of the church tell us that this is true, and they all talk to God personally, so we can trust them. And that's how we know that the religion is true. It's just not a very good argument, right?
Correct. But there's a difference between people that say that they heard from God that don't have empirical evidence of it, and people that have gone and done measurements. So it's a bit of a disjoint to compare them.
Right. But what I'm saying is that, and I might be wrong with this person, I don't know this person's life, but most of the time I'm seeing from the average Joe, not everybody is geodetic surveyors. Most people have not measured the curvature of the earth. So for the most part, you are just relying on what other people have told you.
But they have published things. They have
fiction can be published.
What's that?
Works of fiction can be published.
That's true, but they've actually so to say it's like a preacher that's saying I heard from God, therefore this. Right? And other people can then, for surveyors, can go verify it themselves, right? If you don't think that some basic measurement from a surveyor is correct, you could go rent a theodolite and you
Wait,
could
Toon,
go
you
do the
could,
same thing.
well,
Right?
you could meditate and you could form your own contact with God and you could verify it that way. Unless you contacted God that way and it told you something different, and then they would tell you that you did.
There you go.
So it's, what again, I'm not saying that there's not technology and people out doing these measurements. What I'm saying is to simply assert as your argument that there's all these people who do these measurements. That is a terrible argument. The better argument would be, hey, they're this specific people that made this specific measurement. You know, like MC Tune here. Here's a specific guy who made a specific measurement.
All right. Reaper 22 Actual says, TT, you said you would accept radar measurements. Toon cited an experiment using radar and you played mental gymnastics to not accept it. Titicaca.
Well, I explained the general flat Earth answer for it. And I'll just say that I don't have an answer for it and that I don't necessarily need one. The moon could, in fact, be 230,000 miles away. What do I know?
All right. CV McCullough says, check on PG Tony after his GPS comment. Gary IOW says, EME is a thing. I've done it. That's Earth, Moon, Earth bounce. Stringers one says, an excuse for everything, an explanation for nil. I'm really moving fast here. So PG Tony says, again, I did a GPS survey in the highlands of Papua New Guinea. No ground towers.
A GPS survey.
Yeah.
In the area of Papua New Guinea.
Yeah.
No ground towers. So there are no ground towers anywhere in that whole entire continent.
Papua New Guinea is just an island or series of islands.
And there's no well, you guys just denied, or at least MC Tune, you just denied that there were satellite buoys, basically. Not satellite like it's up in the sky, but there's something bouncing signals that they do have on buoys out in the ocean.
I'm saying that buoys in the ocean are not giving GPS positions.
How do you know?
How do I know?
Yeah.
It's because of how GPS works.
Well, how does GPS work?
It receives a signal from some distant object that the signal includes the time and the location that the object was. You get it from multiple different objects, and it gives their position in three-dimensional space using an ECEF coordinate system. You know what ECEF coordinate system is? That's Earth-centered, Earth-fixed. So everything's relative to the center of the Earth.
Okay.
And a certain line of longitude. And it gives us position in three-dimensional space and the time that it sent the signal. And when you get all of those, then you do a multilateration to get your position. And those positions that they're reporting are not on the ground. They're reporting at some high elevation above the surface of the Earth. So that's how it's getting it. So, and they come from that direction. So if that's what's actually happening, which it is, you can verify that by looking at the source code and write your own source code and all that kind of good stuff. Then a buoy or a cell phone tower sending that same information would not work because that's not its actual position. So it actually have to fake it somehow, and including faking the direction that it came from.
Well, I mean,
not easy to do.
You just
In
have
fact,
to
impossible to do.
Well, I wouldn't really know, to be quite honest with you. I go back to the Gus Gruesome quote where he's like, our simulations are so good, and I imagine that he's including the data simulations in there as well, because there's a back end that has to make sure that everything is going right for the launches. So real or not, you would want really good simulations. And if they're able to send data that you're not able to determine if it's from the real thing or not, then how is somebody that's less than the cream of the crop, not from NASA, supposed to determine?
It's a totally different thing, though. All right, we got to keep going.
Go ahead.
Many Karen says, which has more trolls, Azeroth or Flat Earth?
What's Azeroth?
It'd be a fantasy realm.
Oh,
with
probably
trolls.
Azeroth.
With trolls in it. The grumpy old mechanic says the contempt this guy shows for the hard work of thousands and thousands of experts is infuriating. There you go. Lael says, is TT related to CC? You really need to check in on CC. Westchester County? I think you'd love him. Just last weekend, he was at a meetup in Connecticut with Dearth. You know Dearth, right?
Yeah.
Let's see. Tim Pryor says, I forgot the historian's name, but he said nobody since the 3rd century BC believed the flat earth except uneducated people. So there's it could be Jeffrey Burton Russell. So this book here actually goes over the history of people understanding the shape of the earth. So that web page I mentioned earlier, it's inspired by this book. So Lael says, if Cuba is less than the distance to the sun, why does the limit of our vision not prevent us from seeing the sun? Well, that's a good question.
I'm sorry, repeat it.
If Cuba is less distance than the sun, then why does the limit of our vision not prevent us from seeing the sun? Right? If you said you can't see Cuba because that's the limit of our vision, but why can't we see but the sun's farther, so why can we see the sun?
The sun is higher.
So?
What do you mean so? The angle is much greater, so you're able to see it.
So?
Versus the low angle that is from Cuba.
So?
Just observation angle, field of vision.
But why does the angle have anything to do with it?
Are you serious?
Yeah.
The angle at which you view an object, it has nothing to do with how much it's going to be perceivable as it goes off in the distance.
You still get the light from it, though.
Lower objects are going to be harder to see than objects that are high up in the sky. Just like if you were higher up in the sky, you would be able to see a greater distance. It's just the inverse of that. To try to pretend that doesn't happen is ridiculous.
It actually doesn't happen on flat Earth, but that's fine. PhD Tony is getting after your pronunciation of sphericity with an I, not spherosity.
I like spherosity better. Deal with
it. Timbo Turtle says, super chat, that's a cat treat for Turtle. Turtle's my cat. And Timbo Turtle, I renamed to be spelled with a P at the beginning. Just like my cat is named Turtle with a P at the beginning. Fact Base says, uh-oh, I had one brain cell. There it goes. Darren DeBaron, a.k.a. Lovebot, says, I've changed my name. Beat Boop. Show more love.
Nothing wrong with that.
I don't know. Fa of the QTube family says, the general flat earth answer is nuh-uh. PhD Tony says, I've spent 30 years studying the Earth's shape and gravity field full time with state of the art techniques. This guy just declares it's all wrong.
It's all wrong, dude.
There it is. He did, Tony. Gary IOW says, when I camped in the outback of Australia, my mobile phone did not work, but the GPS in the car worked just fine. Go figure.
Signal attenuation, yes.
Why do you think that the GPS could reach farther than the cell phone?
It's a stronger signal.
And you have measurements of this?
Is it not are you going to assert that it's not a stronger signal?
You're the one made the assertion. Anyway, all right. Tim Pryor says, so he believes in flat Earth with less evidence than he will accept from the globe. That's the last one.
That's funny. Yeah, I mean, I would. So again, my biggest issues with the claims, and again, if we can avoid it completely, and then even put it into the realm of like where we can do it ourselves, and it's not just in a inference, right? Where purely just a calculation, right? So I actually got hit with this in a debate last night. It's like it was the same thing to do with the direct versus indirect measurements. I was saying that, well, you're just inferring the curvature based on how much things are dropping. And I said, well, how is speed calculated? And I was like, and is speed a measurement or is it a calculation? And it actually stumped me for a second. I was like, wait a second, it's both. Because the speed is a measurement of or a calculation between the distance traveled and the amount of time that it takes you to travel it. But it's also a measurement because it's something that you can measure. You can physically measure somebody moving through time at a certain rate, right? Which would be their speed. But with the curvature, again, all we have is the spherical axis and the things are dropping at a, granted, at a pretty consistent rate per distance. So what flat earth would have to do is they'd have to come up with a different mechanism for why that happens. And that's why I like the stuff coming out about the hyperbolic space and the way that we're seeing vision. So again, it's just budding, still learning more about it. But I don't like to make claims to like know for certain. So when someone says that, oh well, you're gonna make this claim, you must obviously know it, for absolute certain. Not necessarily. I don't claim to know anything really. I don't think science really proves anything definitively, but I think that we're doing our best to come up with something that is closest to reality as we can. So, yeah, that's all I have for it.
All right. There's more that came in while you're talking.
Geez, sorry.
But it's funny. Fact Base says, imagine Mikey Smith eating alphabet soup. Imagine. And Caucasian Sensation says, so flat earth is a religion then. And this will be the last one. This is it, people. Fa of the QTube family says, I've lost my GPS signal driving in tunnels, but my cell phone can still stream music and make and receive calls. Please explain.
Got me there.
Awesome. Well, Troubling Tribune, thank you. Thank you for sticking around for to the end here. It's been a good chat. I hope if some people are wanting somebody like you to host a debate, I'll definitely give you a call.
I really appreciate it. That's like the main bread and butter. That's what I love to do. And I very much, I feel the vibe of the contrarian. I do like to just argue things, but don't let that take away from any of the veracity of any of the claims made here tonight. Always do your own research, do your own heavy lifting. And yeah, you'll be doing good. Nothing wrong with challenging preconceived notions or things that we think to be 100% true.
All right. Well, and your channel is Troubling Tribune?
Yep. Troubling Tribune on YouTube, TikTok, Rockfin. And I actually really need everybody's help with this. If you want to see more True Earth debate action over from the TikTok side, then I need help on my backup channel getting to 1,000. That way, if they ban one, I can just go to the other and we can keep things running smoothly. So if you guys like this kind of stuff, go on over to Mr. Tribune over on TikTok. It's the same label that you guys seen in this thumbnail, except it's blue. So you can't miss it.
Right. What if you're colorblind?
Oh, man.
You're screwed.
You're screwed.
All right. Well, thank you. Thank you, everybody. Stick around. I'm going to pop over and see if Sin Cleanser wants to have a chat. But thanks a lot, Mr. Tribune. We'll see you again sometime.
MC Toon, great chat, man. Thanks for having me.
All right. Bye.
See ya.
Record.